What's up, everybody? Welcome on in. What's up, everybody? It's like Lisa's in here. David Tokar is in here. Who else we got in here? Got Julie in here. What's up, Julie? We got Debbie in here. What's up, Debbie? We got Peter in here. What's up, Peter? Lisa's in here. Happy 4th of July. It is 4th of July my time now. It's 12:08 my time. So happy 4th of July. Happy Independence Day to all of you. So, so very awesome stuff. So very cool stuff. Yeah, so let's let you all trickle in here for a few minutes and then we will get started here. I am a Blackhawks fan, Shane. I am a Cubs fan. I am a Blackhawks fan. I am a Bulls and I am a Bears fan. So Chicago. So I'm an all Chicago guy. That is correct. Yeah. So with that, um, so cool stuff here. So pretty cool stuff here going on. I got some new overlays here. I am introducing Streamlabs into my chats and trying to just get some more interactive with each other, things of that nature. So definitely good and great to see you all in here. So pretty awesome stuff. Really awesome stuff. Um, so it's pretty cool. So hopefully, you guys can play some games there. There are some different other things. Um, so it's cool. Cool ways to stay interactive and cool ways to stay, um, you know, uh, just interactive going on. So yeah, so just very cool stuff. But yeah, so chatbot should be working, should be going, should be in there. So uh, hopefully set them up properly. Will somebody type in exclamation point Papa John, please, and see um, if his YouTube pops up? I'm gonna see if I did that correctly. So somebody type in exclamation point Papa John, please. See what. All right, cool. We got it. I want if it's linked. I don't know. Can we get to it from the? Can you click on the link there and get to it or not? If not, I'll have to hyperlink it if it's not hyperlinked, but I'll figure that out eventually. Um, but at least that's working. So at least we can see that. Um, when it comes to that, yes. And if you okay, good. Link works. Yeah. There's a pull up. So hopefully you guys will. Hopefully we can figure out whoever let the dogs out. So we'll just see if we can figure out whoever let them out. Um, but yeah. So go ahead and play along with that. Mystery, there. So see what you got right there. So you should see the poll up. Should see my live subscriber count. Looks like I have 410, which is amazing. So very awesome stuff with that. So very cool. So yes, so should be able to play some tic tac toe. See my subscriber count. Kind of the goal. Just trying to get 28 new subscribers. Things of that nature. Uh, so if you put in, so if you'll be able to, if you type in I vote, or I'm sorry, exclamation vote, you'll be able to vote on the poll. So on the poll question. Um, so see if uh, whoever let the dogs out. I'd like to know what we think about that, right? So I think it's a mystery myself. So on that. But very good stuff today. Very good stuff tonight. It is the 4th of July again, my time. Looks like we got Brother John in here. Thank you, Brother John, so much. Thank you for a great stream. Um, thank you for just everything, Brother John. So thank you so much for that. I really do appreciate that. So, but yeah, so cool stuff. Yeah, so if you put like I vote mystery, I vote nobody, I vote they, that'll get you into well, the poll there, and what the poll is showing. So good. So, but again, who let the dogs out after all these years, after all these decades? I think we need to figure out finally if they know, if it's a mystery, or if it was just the figment of the singer's imagination and there were no dogs to begin with. Um, so, so yeah, so good stuff there. But yeah, and you will see as you vote, you will see your tallies over here. So on that. But yeah, so cool stuff. Cool stuff on that. Hope you guys are having a great day, a great night, on all that. So very, very cool stuff. But yeah, definitely is very awesome stuff. Just so cool to see everybody, hang out with everybody for a while. But like to stay interactive, and hopefully my subscriber count will continue to go up here. So I am 89 currently away from the magic number of 500, which the magic number of 500 is because of obviously that's the minimum number that you need in order to become a YouTube partner. So yeah, but cool stuff. Hopefully, if not, I can figure out the overlay, but well, that's neither here nor there. But hopefully it all looks good on your guys' side. So, good stuff. Great to see you guys. Again, Brother John had a great chase. Just a really great and awesome time. So, yeah, so it's very, very awesome stuff. So, but yeah. So, we'll give it a couple more minutes here, and then we'll kick into some storm chasing lingo, storm spotting lingo. It's basically the same thing. They all use the same thing. Found this nice glossary here that goes over some really good terms of what some great storm lingo is and is used out there all the time. So, figure this would be a great tool to really just help us learn some stuff. And yeah, I learned some stuff myself too. So it's really good to be a part of that with you guys, and everything else. So hopefully again, you guys are having a great day, great night, and we'll kick it off here about. I'll give it about 3 more minutes, so we'll kick it off here about 12:20 my time. And we will dive into that when about 12:20 comes. So very cool stuff, very awesome. Just really, really cool stuff that's going on. like I said, messing around with these overlays, learning more about these overlays and adding in interactions. But I believe you can also play. I believe if you type in exclamation slots, you might be able to play some sort of slot game. I could be wrong. I thought I enabled that. Some sort of way to just stay active and stay interactive in the chat as well. So, but it looks like we got about. Let's see what we got here. So we got currently about 248. So that's very awesome. Very good as well. So very awesome stuff. Very cool stuff that's going on. So I think let me know if the game works. If it doesn't, I'll figure that out for next time. But let me try that. So but from that, so but yeah, it's pretty cool stuff, pretty awesome stuff, um pretty awesome stuff. So I don't remember what the thing is on that, but one more minute and we'll we'll fire away on these and we'll have some fun. We'll have some fun going through a little bit of the glossary here and some terms here. But yeah, please stay active in the chat. I know it's late. I know it's 12, again, 12:19 my time, 1:19 in the Eastern time, and it's also 11:19 Mountain time, 10:19 Pacific time. So, so very cool stuff. But thanks again for joining in. Thanks again for spending your valuable time with a guy like me, so I appreciate that. I'm just a guy in a Chicago Cubs shirt, which they got beat up really badly today, but that's baseball. One day, they just won previously their game before that, 23-3, and then their next game today they got beat 17-1. So if any sport will humble you, it's baseball. So baseball is a very, very humbling sport. So pretty cool on that. But yeah, awesome. Good to see you guys. Great to see you guys. So let's kick in to it's 12:20 now. So let's jump in to the topic. Let's go. So looking at let me blow it up here. So should be better now. I think people can see that now. Looks good. Looks good. All right. So I'm not going to go through all of them. I'm just going to go through the main ones that are used a lot on live streams, used a lot when you hear storm chasers talking, used a lot when you hear maybe some meteorologists talking, things of that nature. So some of the stuff you're already going to know. It's already going to be some regurgitated information, but some of this is going to be new to you, like it was new to myself. So again, appreciate it. Let's jump into it. So all right, so let's look at one of the big things sometimes you might hear storm chasers talk about is algorithm. It's just used a lot in radar and everything else that we know, computers and social media and everything else like that. So algorithm is used to obviously help aid in radar scoping, radar data setting, things of that nature to see. So a lot of computer programs, a lot of set data points, physics, mathematics, and all that can be put in and applied to an algorithm. So if you hear an algorithm, it is a computer program or a set of programs which is designed to systematically solve a certain kind of problem. So that certain kind of problem that we're always trying to solve for in the weather community is, where is the rain? Where is the hail? Where is the thunder? Or I'm sorry, where is the lightning? Where is a tornado? Things of that nature. So an algorithm helps display and helps behind. It works behind the scenes and helps to determine that. And um, the algorithms it help to analyze radar data and automatically determine storm motion. So when you see storm motion, probability, things of that nature, be thankful that an algorithm was programmed inside of that or behind the scenes of that, because that's the algorithm that's analyzing all of that. So it's a computer system inside a computer system. So won't spend too much time on that, but be thankful that is where an algorithm comes from that with that. So the next one we'll talk about anti-cyclonic rotation. So we've all heard cyclonic and tornadoes here in the U.S. spin counterclockwise, but when you get to anti-cyclonic, it's obviously it's the reverse of that or the inverse of that. So that means that an anti-cyclonic tornado is spinning clockwise here in the United States. So again, I'm sure a lot of you have probably heard cyclonic and anticyclonic, but when you hear anticyclonic, that's what it's talking about. It's talking about in the northern hemisphere in the U.S. that it's going to be spinning. So if you're going to in the counterclockwise here in the U.S. and then and then clockwise for the anticyclonic to be an anticyclonic. So, and they're very, very rare, very, very extremely rare. There has to be certain parameters in place for them to be anticyclonic. So they have to be. There's a lot that goes into that. So very, very rare. If you ever see one, count yourself very, very lucky to see and blessed to see one. So anticyclonic, we hear a lot about that. You'll hear about that. Anvil is another one. If you're watching Storm Chasers and they say, oh, there's a big anvil up there, it's just a big cumulonimbus cloud shaped like an anvil. What happens is that it has reached the top of the I don't know if I can't remember if it's a troposphere or ionosphere. One of the spheres it reached the top and it can't go up any higher, so it flattens out and it looks like an anvil. So if you ever hear that and see that looks like an anvil, that means it cannot go up any higher in the atmosphere. It's reached its peak, it's reached its top, so it flattens out and it looks like an anvil. And a lot of times storm chasers will say, got an anvil, obviously in front of us or that we can see. So pretty cool stuff with that. Again, please, if you're new here, please please subscribe. And also, if you like my content, please please subscribe, please share. Please, I appreciate it. If you're lurking, if you're active, whatever, but please please share, please subscribe, and welcome to, a good old topic of storm chasing lingo. And so hopefully that next time you watch some storm chasers and you hear something, it will ring a bell and you can know exactly what they're talking about. So I appreciate that. Thank you guys very much. So thumbs up if you are enjoying, having fun so far, and having a great night. So I definitely appreciate that. Thank you so much. So we'll talk about next. We'll go into the bees here. So again, we'll talk a little bit. Again, this is going to be some regurgitated information. Again, not going to read everything, but just the main things that you will hear in storm chasing. So when it comes to that, so Bear's Cage, we talked quite a bit about that previously. Bear's Cage, again, the Bear's Cage it's a tornado. The tornado is the bear, and the cage is the rain. So it's associated with a HP storm, which is high precipitation, which that's actually another verbiage on here. But yeah, so the bear, remember the bear is the tornado, and the cage is the precipitation that the tornado is wrapped around. So it could be rain, could be hail, could be debris, could be everything else. So inside of that, so the cage is made up of many things. So don't ever tempt the bear, and don't ever try to wrestle the bear. So then we look at another one. That's another that you hear storm chasers talk about is a boundary level. Boundaries create different atmospheres just on one side of the boundary. So in general, it's a layer of adjacent. Sorry, it's in general a layer of air adjacent to a bounding surface. Specifically, the term most often refers to the planetary boundary layer, which is the layer within which the effects of friction are significant. So basically, what it's just saying, there's on different sides of the boundary, you could have, it could be warmer, it could be colder. So you got your different fronts, things of that nature. So when you come to that, so a lot of times you'll hear boundary layers. You'll hear them saying, there might be different boundary setup, outflow boundary, things of that nature. So that's one thing that you might hear as well. So, but you know, the boundary, it is a boundary between two different air masses, through two different atmosphere layers there. So boundary, it is what it is. So it's like a fence. It's like a fence that's put up. So if you hop over one side of the fence, you'll experience one form of weather. You hop over the other side of the fence, you'll experience a different form of weather. So boundary layer. So you'll hear that quite a bit on storm chasing channels. So that is boundary layer, just in a high level overview. So, and then Debbie says, I am going to bed there, John Boy. Thank you, Debbie, so much. I know it's late. I appreciate any of the time that you spent tonight. Thank you so much. Appreciate all of your support, your encouragement, and everything. So thank you so much, Debbie. God bless you, and you have a great night tonight. Thank you so much. All right, so move on to Bo Echo. Bo Echo is going to be probably a little bit of regurgitated information here. That's going to be, Bo Echo is going to be like your deratios. It's like a bow, right? When you pull a bow back, it becomes a backward C, things of that nature. So Bo Echo, I believe that everyone's pretty much aware what a bow echo is, and things of that nature. So but yeah, so bow echo is another one that you're going to see. But just to get into a little bit, a bow echo is a radar echo, which is linear but bent outward with a bow shape. So linear means it's just a straight line of storms. So you will hear, and we'll get into that too, it's called storm mode. You'll hear storm chasers say, well, I don't know what the storm mode is going to be today. Is it going to be linear, or is it going to be discrete? So linear means that they're going to be lined up in a line. Discrete means that they're going to be not in a line, and that they're able to pull in all the air mass around them. And so discrete supercells are the most violent, because they're able to suck in and utilize all of the atmosphere around them, instead of being linear in a row of storms, while all of the storms are competing for the same air mass in the same atmosphere. So they end up, in a long nutshell, they end up just cutting each other off and everything like that. So does Shy Winnie Mom Tammy says, thank you, Shy Winnie Mom Tammy, for being here. Appreciate that. Thank you so much on this early morning of July 4th. Does the Bow Echo cause QLCS tornadoes? It can, yes. So in a QLCS, which will bow out in a line, yes, there can be, and a lot of times there are, spin up QLCS tornadoes. So you get little notches in the line. They get more just in a higher just kind of more like a layman's term. So what happens is when the storms are in a line, you get some storms that'll kind of jut out just a little bit from the other ones, so they'll suck in a little bit more air and they can start wrapping and start rotating than the other storms that are around them. So they'll pull in some more inflow, and then there'll be some quick, brief spin up tornadoes. So yes, QLCS tornadoes. The Bow Echo does and quite often cause QLCS tornadoes, and again, they're fairly quick, fairly roughly. They usually don't get any higher than EF2s, things of that nature. But again, as we know, it doesn't matter what the EF is. Tornado is damaging no matter what. So yes, so definitely to answer your question there. And Tammy says, just call me Tammy. Definitely. So thank you so much there, Tammy, for your question. So from that, so awesome job. Thank you, Tammy, so much. So we will continue on here to get into the C's here. Cap. Cap is a big term used that you would hear storm chasing. So, and you're welcome there, Tammy. But cap, I think we've probably all heard that. If there's going to be a cap inversion. So basically, in a nutshell, what a cap is, it's putting a lid on any type of storm initiation. It's putting a lid. It's keeping the environment stable. So there's a cap on it. It's like a ball cap. It's like, or whatever type of illustration you want to use in your mind. So what happens is when that cap starts eroding and a cap starts breaking, and once that cap fully erodes and breaks through, then storms can start firing up. But if that cap is in place, those storms will not fire up. So just to kind of get into a little bit of it. So a cap is a layer of relatively warm air aloft, usually several thousand feet above the ground, which suppresses or delays the development of thunderstorms. Air parcels rising into this layer become cooler than the surrounding air, which inhibits their ability to rise further up. So as such, the cap often prevents or delays thunderstorm development, even in the presence of extreme instability. However, if the cap is removed or weakened, then explosive thunderstorm development can occur. So if that cap is there, if the air particles can break through and rise taller, then the cap erodes. It's called cap erosion. So once that cap erodes out, then that's when the strong thunderstorms can take place. So, but yeah, so that's what it occurs for. So it's little air parcels that rise. It's little air parcels that rise into this layer, and they are cooler than the surrounding air, so they can't not rise up any further. So when it comes to that, so Lisa says, "Thank you for the detail on cap. I never understood why it occurs." You're welcome, Lisa. Julie Rio says, "Cap or no cap?" I'm going to say that cap is it's capping. Cap is doing much capping as it can. So, but for storm chasers don't want they don't want there to be a cap, because storm chasers obviously want storms to fire. That's how they make their money. That's how they do things. So if there's a strong cap in place, even with instability, that cap can prevent and does prevent thunderstorms from firing off. So a little bit on cap there, not to be confused with its next one here, which is CAPE. CAPE. So there's cap. Remember, cap is a lid. Everything's trying to rise up, but the cap says, no, you're not going to go anywhere. You're going to be stable. You're going to be stabilized here. But once it starts eroding throughout the day, then these little particles start breaking through, and then it finally erodes off. Then again, that's the cap. Then we have CAPE, which is a big one that I'm sure is probably a lot of regurgitated information when it comes to storm chasing, things of that nature. But convective available potential energy. So in a long nutshell, what CAPE is, it's instability, it's rocket fuel, it's it's that's in a nutshell. That is what CAPE is. So when storms tap into what the CAPE is measured by joules per kilogram. So as you see here, it is J/kg. That's how it's always written. So usually they say about 1,000 joules per kilogram is really what is really needed to get thunderstorms to really start firing off and to be really unstable. So once you start going into the 3,000s and the 4,000s and the 5,000s, you're talking about extreme volatility and an extreme amount of energy that these storms can tap into. So it's basically, and as it states here, CAPE is directly related to the maximum potential vertical speed within an updraft. So thus, higher values indicate greater potential for severe weather. So when you hear storm forecasters or you hear storm chasers talking about CAPE, that's what they're looking at. They're looking at to see where this joules per kilogram is at. So they're looking to see, if it's in the 2,000s, 3,000s, how much fuel for the storms is out there. And so that is CAPE in a high level overview of that. So won't spend too much time on that. Pretty sure that that's a lot of people that you guys know a lot about that. So CC, we talked a lot about this yesterday. CC, right? Cloud to cloud lightning. So you guys should all be familiar with that. A cell, so like a storm cell here is just a convection in the form of a single updraft, downdraft or updraft/downdraft couplet, typically seen as a vertical dome or tower. So just talking about a cell there. So, and a thunderstorm typically consists of several cells. So that is usually within thunderstorms there. So, and so we go on to CG. CG is cloud to ground. We talked a lot about that yesterday as well. So you all are should be familiar with that. But if you were not here for yesterday's, so if you were not here for yesterday's weather session, I'll call them, or weather seminar, we talked about lightning. So CG. So when you hear CG again, when you hear storm chasers say, "Oh man, I just got a clear view of a CG. There's a bunch of CGs around me," or things of that nature, they are talking about cloud to ground lightning. So CGs for that, and again CCs for cloud to cloud. So a lot of storm chasers forecast, whomever you might be watching, Max Velocity, Ryan Hall, y'all, people like that. They will also say CGs or CCs, which is cloud to cloud lightning. So, and we also get into another what CC is as well too. So, and then so here's another here's another that you might hear. It's called the clear slot. Clear slot. This is sometimes referenced on quite a few storm chasing channels. Storm chasers like to use this word as well. So it's a local region of clearing skies or reduced cloud cover, indicating an intrusion of drier air. So often seen as a bright area with higher cloud bases on the west or southwest side of a wall cloud. So if they're looking at the wall cloud and they're and a lot of storm chasers like to point out what they're looking at, a lot of times you will hear this lingo come up called clear slot. So a clear slot is believed to be a visual indication of an RFD, which is a rare flank downdraft, which is another part of this lesson as well. But yeah, so if you hear clear slot, it's a local region of clearing skies or reduced cloud cover, indicating an intrusion of drier air. So that's drier air that's being sucked into the storm there. So that is So that's your clear side. That's an indication that there's drier air being sucked into that storm. So, and as again seen as a bright area with higher cloud bases on the west or southwest side of the wall cloud. So if you hear clear slot, that's what clear slot is. So, Tammy says, I'm sharing these lessons with my sister. She's going to be my navigator when we start chasing. Tammy, that is awesome. That's best of luck to you when you do start chasing, you and your sister. That's very awesome. So thank you so much for that, and thank you for trusting in me to give you reliable and trustworthy information. I appreciate that. Lisa says, visual indication of an RFD. Did not know that. Yep. Very good stuff. So again, clear stuff. Great job, Lisa. Thank you for that. So clear slot if you hear that. So sometimes you might hear this, very rarely, but I've heard it before. Cold air funnel. So cold air funnel is a funnel cloud, a small, relatively weak tornado that can develop from a small shower or thunderstorm when the air aloft is usually cold. They are much less violent than other types of tornadoes. So very rarely though we hear this, but I've heard it before. So yeah. So cold air funnel. So a lot different than the other funnels that are in tornadoes that storm chasers might be going after, but sometimes they might encounter or talk about this here. So cold air funnel. Tammy says, last time I chased was 1994. Times have changed a lot. Yeah, I'm sure they have. I would assume, hopefully for the better, hopefully with better radar, hopefully with better information, hopefully with better algorithms, hopefully with better data, and just better all around people that are out there chasing, better around just, vehicles. So hopefully that is a plus there. So when it comes to that, so. Another one that I've heard quite a bit before is cold pool. Cold pool, some storm chasers will like to talk about this and say this. It's a region of relatively cold air represented on a weather map analysis as a relative minimum in temperature surrounded by isotherms. So cold pools aloft represent regions of relatively low stability. So while surface-based cold pools are regions of relatively stable air. So cold pools aloft they represent, just in a nutshell, they represent regions of low stability or instability. So a lot of times storm chasers and everything, they'll be looking for what's called the cold pool. So that is, sometimes you might hear that. So collar cloud. I've heard Freddie talk about this before. Freddie McKinney on one of his streams. I've heard it, I believe, on another storm chaser streams as well. But the collar cloud, what you have to look out for, it's a generally circular ring of cloud that may be observed on rare occasions surrounding the upper part of a wall cloud. So collar cloud is not a wall cloud. So it's a generally circular ring of cloud. So it's circulating. It's a ring, and they're observed on rare occasions. But you'll hear storm chasers talk about the collar cloud. So that is just if you hear that, you can know that's just a general circular ring of cloud. It's very rare, but it's usually surrounding the upper part of a wall cloud. So. Tammy says, all we had were paper maps, and paper maps. Okay, we're talking like atlases and stuff, then probably that was before even MapQuest days, and before we had to print out MapQuest, to go everywhere. So, CB radios, yep, and our wits. Today's technology has made it safer. Awesome. Thank you, Tammy. So, appreciate that so much. So, all right, so we will move on from collar cloud. Another big thing that you guys have probably heard a lot is condensation funnel. So condensation funnel or condensed funnel. So a funnel-shaped cloud associated with rotation and consisting of condensed water droplets. Compare that. Sorry, it's talking about comparing with debris clouds. So that's what it is. So when a condensation funnel, you'll see it coming out of the sky. You'll see it coming down. That's what we get to see a lot of to the visuals of a funnel cloud coming down, touching the ground. So to be fully condensed, what that means, fully condensed, and then that's what a condensation funnel. That's exactly what it is. It's a funnel-shaped cloud associated with rotation and consisting of condensed water droplets. So that's what a condensation funnel is. So from that, I won't spend much time on convection. I think we all pretty much understand what convection is. That is, convection is generally transport of heat and moisture by the movement of fluid. So we're talking about convection type of thunderstorms, rain, things of that nature. So convection, I think we probably all know quite a bit about the convection there. So, but if not, I'll just briefly go over that real quick. And again, it's generally transport of heat and moisture by the movement of a fluid. In meteorology, the term is used specifically to describe vertical transport of heat and moisture, especially by updrafts and downdrafts in an unstable atmosphere. So the terms convection and thunderstorms are often used interchangeably, although thunderstorms are only one form of convection. So CBS, towering cumulus clouds, and Aka's clouds are also visible forms of convection. So a lot of times you hear storm chasers say, I wonder how much convection there's going to be today. Are we going to have a lot of convection today? So again, they're going to be talking about thunderstorms. Some also might be talking about clouds, things of that nature. But when they're talking about convection, mainly they're talking about the formation of thunderstorms. So that's convection for you. And then convective outlooks. We talked about this before. This is the day ones, the day twos, day threes, all the way from day 4 through day 8 from the National Weather Service, SPC. They give us what are called the convective outlooks, and that's what those are. So very cool on that. And here we go. Core punching. That's a big term, right? That's almost used. I believe Brother John just said that in his stream when I was watching. So I believe he did say core punching. I could be wrong, but core punching, it's a slang term. It is when a vehicle drives into heavy precipitation core of a thunderstorm. Usually it means punching the core, the hail core, things of that nature. So it's usually hail that's being punched. So that's what core punching is. Core punching is punching in the middle of the core or the core of the thunderstorm. So if you hear core punching, that's what they're doing. So we will move on. We'll skip over that. Cyclic storm. So if you hear a storm chaser say this storm has been cyclic, that means it's cycling. So what that means is if a storm is cyclic, if it's cycling, that means it's dropped a tornado. We'll just say it's dropped a tornado already, right? Now the tornado has lifted back up. Now it's going through cycles. It's cycling back. It's gaining strength. It's intensifying, things of that nature, and then it drops another tornado. So, thank you, David Gendron, for subscribing. Thank you for that. I appreciate that very much. Thank you very much, brother. And so, cyclic storm is the same as saying cycling. So if you hear people say cyclic, sometimes they will always say the word cyclic, and they say, that's the storm is cycling. So, or if the storm is cyclic, that just means that the storm is cycling. That means that it's going through different phases and it's gathering up strength, and that it is getting stronger, and that it is going to try and drop, if it does, another tornado. So a lot of storms do cycle. A lot of storms do drop tornadoes. They go through a cycling process, and then after that cycling process, they will either not produce another tornado or they will drop another one. And there's many times where storms have gone through multiple cycles and dropped multiple tornadoes. So that's what is meant by cyclic storm. So DBZ. This is seen on reflectivity, which is radar. So this is seen on radar. So the higher the value of DBZ means the more intense the rain, the more intense the hail, the more intense that it is. So if you were to look at, sometimes you will, Brother John will look at DBZ. A lot of other storm chasers will look at DBZ and they'll go, oh, wow, that storm's at 60 DBZ or 65 DBZ, just to give you an example. So when that comes in. So, but real quickly here, it looks like we got Michael, Michael 808 Alpha is in from Hawaii. Thank you, Brother Michael, for being here. Definitely appreciate that. Thank you very much, sir. Appreciate that so much. So DBZ. So you can look at DBZ on multiple radar apps. You can look at them on WeatherWise, Weatherfront, Radar Omega, all the other ones, and they'll tell you. So when you look at that, and you're usually looking around for the hail, and if when there's usually hail in it, then you're probably getting up into the 60s, 55, 60s, 65, things of that nature. So so that's just reflectivity, and it's decibels per reflectivity. So that's what it is in decibels. With respect to radar, it's reflectivity with the factor of Z. So that's how it is. That's how it is. So DBZ. All right. After DBZ, you will hear, sometimes you will hear storm chasers talk about this, which if we see this, this is not a good thing. The debris cloud is not a good thing. I repeat, the debris cloud is not a good thing. So, as we know, debris cloud, it's a rotating cloud of dust or debris near or on the ground, often appearing beneath a condensation funnel, yes, often appearing beneath the tornado, and surrounding the base of a tornado. So if you see this, so debris cloud is obviously is a prime indication of what is happening on the ground, that the tornado's on the ground, it's doing a lot of damage, things of that nature. So when it comes to that, so debris cloud, not nice. We definitely don't want to see a debris cloud because that means that's a lot of damage going on. So Lisa says CC drop. That would be definitely a correlation coefficient drop. Definitely that would definitely come. You would be able to see the debris cloud there. You would see the on the correlation coefficient radar. You would definitely see a CC drop and be able to see a debris ball. So great. Yes, great point out there, Lisa. So again, we talked about CC, and I'm glad that Lisa brought this up. CC is actually, there's two terms for CC. CC is cloud to cloud, but when you also hear CC drop or CC radar, storm chasers are talking about correlation coefficient radar or a correlation coefficient drop. So which is the radar. So great point out there, Lisa. Yes. So in storm chasing, CC has two terms: cloud to cloud and correlation coefficient. But yes, the debris cloud is something that we don't want to see. So it's never a good thing to see the debris cloud. So Duratio, if you guys were here, for the people who weren't here for one of my weather sessions a couple of days ago, we talked about Duratio, and that is just in a broad term. It's 240 miles. It has to go over 240. It has to be 240 miles or more. It has to have 58 miles per hour of wind throughout the whole process or throughout its whole lifespan, and there has to be at least 3 reports of 74 miles an hour or more of wind damage inside of that, inside of its span of 240 miles or more. So that is a derecho in its full definition of what a derecho is. So when it comes to that, and a lot of times you will hear hear a lot of damage because they are damaging, because a lot of times they're 70, 80, 90 mile an hour winds that go over a swath of like 400, 500 miles. And sometimes the line itself will be, 200 mile an hour, 200 miles long or 100 miles long, or however many storms that got into a line, that went linear and got into a line. So that's why you always hear a lot of damage reports coming out of a derecho. So derecho there. Dew point, I think we're all pretty much familiar with what dew point is. It is just a measure of atmospheric moisture, how much moisture is in the air. So if dew points are high, that's a good indication there's a lot of moisture in the air, which is needed for convection, which is needed for thunderstorms, which is needed in order to make and create tornadoes. So a lot of times people will go, oh, yeah, the dew point is 70 degrees today, it's 72, dew points are high at 68. So that's a good indication that there's a lot of moisture in the air to help aid in convection. So with dew point. So move on for that. So talk about Doppler radar. We're all, I think, pretty familiar with what Doppler radar is when they talk about radar on a live stream or things of that nature. So downburst. Again, this is a strong downdraft resulting. Sometimes you'll hear, oh man, there's a huge downburst. We just got hit by a downburst. A lot of times they'll say a microburst, which a microburst is inside of a downburst. So a strong downdraft resulting in an outward burst of damaging winds on or near the ground. So downburst winds can produce damage similar to a strong tornado, although usually associated with thunderstorms. Downbursts can occur with showers too weak to produce thunder. So again, if there are strong downbursts and there's even stronger microbursts inside of those downbursts, that's why you see a lot of straight line damage. And like if you ever seen like forests, like if a downburst hits a forest, whatever, you'll see a whole like row and line of trees that's down for like, as far as the eye can see. So downbursts can be and are very dangerous. So let me stop there at downburst right now. Looks like we got still 157 people here at 1 a.m. Central Time, which that is awesome, on 4th of July. So questions, comments, concerns. You guys still having fun? Still enjoying learning? Hope you are. Please let me know in the comments how you guys are feeling and everything else. So appreciate that. And again, appreciate you guys spending your 4th of July time so far with me in my Cubs shirt. So, but highly thank you for that. So hopefully you're learning. Hopefully you are learning things, maybe some different lingo here. This all, again, might be stuff that you already know, but if not, hopefully this is some learning for you as well. And at the end here of this, I'll show you where you can find all these glossary terms at, so you can, see for yourself and help yourself with that as well. So, all right. So if there's no questions, no comments, no concerns, again, appreciate 156 of you being here. So very thankful for that. Very awesome. See brother Shane. Thank you very much, Shane, with a thumbs up. Thank you, Lisa, with a thumbs up as well. Very thankful for that as well. So, but yeah, so let's move on. So we're in the D's here. And again, we'll fly through this stuff here. I'm just going to pick out the ones again that are pretty well talked about, on live streams and in forecast and in videos. And so just just so you can get a little bit more acclimated with that. So a big one here that you will hear a lot is, where is the dry line going to set up? Raise your hands or thumbs up if you've heard that a lot in storm chasing videos, saying where's the dry line going to be? Where is, where's the dry line going to set up today? Things of that nature. So I know I've heard a lot, and I would assume that you all have heard it a lot too. So when it comes to that, so but what they're actually talking about, what they're talking about with that dry line is it's a boundary separating moist and dry air masses. So remember, it's the dry line is a boundary, it's a fence. So it's a fence. So as it moves, it's a moving fence that's separating moist and dry air masses. So, and an important factor in severe weather frequency in the Great Plains, which we know the dry line plays a big pivotal role in severe weather out there in the plains. So it typically lies north and south across the central and southern high plains. So it'll usually be north to south. So, and states during the spring and early summer, where it separates moist air from the Gulf of America, which I believe that's going to be Gulf of Mexico, I believe. Not 100% sure. Never heard of that. So when it comes to that, so moist air from the Gulf of America and dry desert air from the southwestern state to the west. So the dry line typically advances eastward, as we see on maps and everything else, during the afternoon and retreats westward at night. So a lot of people don't know that. So during the afternoon, it's going east, but then the dry line, once the nighttime kind of starts setting in and everything else, due to the atmosphere and everything else, it starts to go back to the west. So, however, a strong storm system can sweep the dry line eastward into the Mississippi Valley or even further east, regardless of the daytime. So you do need a stronger storm system to push it forward east. But yes. So that's kind of an unknown sometimes for the dry line, is that it does go back to the west at nighttime. So, but yes. So when you hear dry line, it's a boundary, and it's a boundary for severe weather, because severe weather, you need moist air. Severe weather doesn't like dry air. So for severe weather, you need the moist. So wherever side that dry line, wherever side that moist air is on, that's going to be where a lot of the severe weather is going to be at. So, so again, dry line is very, very talked about a lot in a lot of storm chasing videos and live streams. So, and this just goes in with the bulge and storm and things of that nature. So, on that, so we talked a little bit about microburst already. That goes inside of what we talked about. So, here's another one that is also talked about too. Is we talked a little bit about the clear slot. But here's another one too that's talked about on live streams and storm chasing in the community as well, is the dry slot. So a zone of dry and relatively cloud-free air which wraps east or northeastward into the southern and eastern parts of a synoptic scale or mesoscale low pressure system. A dry slot generally is seen best on satellite photographs. So we have a clear slot and we have a dry slot. So a lot of times what they're looking at radar and things of that nature, you'll see them talking about dry slot. So that is dry slot for you. The other night we talked about what a dust devil is. Dust devil is a small atmospheric vortex not associated with a thunderstorm, which is made visible by a rotating cloud of dust or debris. Dust devils form in response to surface heating during fair, hot weather. They are most frequent in arid and semi-arid regions. So that's why in the desert, here in the United States, in the deserts of Vegas and California and Arizona and things of that nature, New Mexico, you see a lot of dust devils because of the heating during the day, and they're super hot. It's things of that nature. So that is why you will see that. So, and thank you, Corey Adair, for just becoming a subscriber. Thank you very much. Appreciate that. Thank you so much. So, but yes, so that's what a dust devil is. It's not associated with a thunderstorm at all. It's a fair weather rotating cloud of dust or debris. So when it comes to that, so. And we'll move into E. Sometimes you guys might be when storm chasers are talking about different models and forecasting models that they use. A lot of big one they use is what's called the Euro model, or the European Center for Mid-Range Weather Forecasting, the ECMWF. So sometimes if you hear Euro model, you're talking about this ECMWF here. So I've heard that a lot on storm chasing. So we're talking about that. We'll get into here is one thing that it's not really per se to storm chasing, but more to the SPC. They put in what is called enhanced wording. So what that enhanced wording is on the watches and or the when the watches that they put out, they'll put, oh, this is a particularly dangerous situation with the possibility of very damaging tornado. So they have the option of adding in these enhanced wordings. So when we see wordings like PDS, extremely damaging winds, things of that nature, that is what is called enhanced wording. So enhanced wording is never a good thing that we want to see in watches. So but when it goes to that, so we'll talk about. We'll move on here. The Fujita scale. Obviously, that's now the EF scale. So it was the Fujita scale. It became the enhanced Fujita scale in 2007. So even tornadoes that were rated before 2007 on the F scale are now considered EF tornadoes. So that's Fujita scale. That's how we rank tornadoes here in the United States, is on a scale of EF0 to EF5. And there's also another one, which is a lot of people laugh at, which is called EFU. So I didn't make that up. That is an actual, real, true thing. There's an actual thing from the National Weather Service in the Fujita scale. It is actually called an EFU. So and so that is so yeah. And actually a lot of tornadoes get rated EFUs, which to me I think is like a really hilarious pun to that. But a lot of tornadoes get rated that, which means undefined or undetermined. So because they don't either have enough information to determine it, they couldn't get out and survey it, there's not enough radar data, things of that. So many tornadoes actually fall into the EFU category. So pretty something, if you ever have a few minutes, look that up and you'd be like, oh wow, I didn't realize that many tornadoes fell into the EFU category. So Shane says, why was it ever renamed? So it wasn't technically ever renamed. They just put the enhanced in front of it, right? So I guess if that's what you're talking about, right? So they put the enhanced because what they did was they went back and added in more ways to describe and ways to figure out a tornado. So what they did was so they added in more damage indicators. Like, so the old Fujita scale, you didn't have damaging indicators like trees being debarked, cars being flipped over. You didn't have certain things like that back in the day for that. So once they got together in 2007, they said, hey, we need other damaging indicators instead of just a house being slabbed or things that the thing. So that's why they put the E in front of it and said enhanced, and they were able to calculate different wind speeds off of that. So that's why that guy ended up getting changed to add in more damaging indicators to that. So give me 1 second here, and I will be right back. All right, back at it. All right, so here I'm actually gonna pause here in about 5 minutes, and I'm going to take about a 15-minute break. And if you guys are still here, I appreciate that. But a 15-minute break. To lay with putting my son to bed, things of that nature. So, but yeah, in about 5 minutes, and then I will be back. Take about a 15-minute break. So, but moving forward, Shane says yes. There's a name for everything. It seems blizzards are now bomb cycles or bomb cyclones. Yes. I'm bad with change or can be. Yeah. So, but yeah. Nor'easters, right? Sometimes you hear the word nor'easter too when it comes to things of that nature. So, but yes, so that's why they changed it. They were able. They said, hey, we need more damaging indicators. We need more things that go off of than just what the original Fujita scale had in place. So, so yes, so they were able to again to bring back the winds because before, if you look at the as we get into this here, if you look how the F5 was previously rated. The F5 was previously rated from 261 miles per hour to 318 miles per hour. Well, now the EF5 drops all the way down. So now the EF5 drops all the way down to 201 miles or more. So anything over 200 miles is an EF5. So you can see the winds drop significantly in the new EF scale. So that's another thing. So let's go back up here a little bit. One thing you might hear too is feeder band. So it's a line of bands of low-level clouds that move or they feed into the region of the thunderstorm. So you might sometimes a lot of storm chasers who are into meteorology and things like that. A lot of times they'll see the feeder bands and they'll say, hey, here comes the feeder band into the thunderstorm. So if you hear feeder band, they are talking about a line of or bands of low-level clouds that feed into the updraft region of a thunderstorm, usually from east through the south. So when it comes to that, so feeder bands, that's what feeder bands are. So here we go. Forward flanking downdraft. So this is the opposite of the rear flank downdraft. So your FF, so you have an RFD and you have an FFD. The FFD is going to be it's the main region. It's the main region of downdraft in the forward or leading part of a supercell where most of the heavy precipitation is. So what that is, so when you're seeing like a big core of hail, you're seeing all the rain and you're seeing all the big, like the big, huge, circular storm, things of that nature, that's all the forward flank because it's moving forward. So the winds aren't wrapping around it from behind like they are in the rear flank downdraft. So forward flank. So in a storm, there's a forward flank downdraft and there's a rear flank downdraft. So in a supercell. So the forward flank is going to be all your big hail, your rain, your majority of your rain, all that precipitation. And then the rear flank, as we have talked about and discussed before, the rear flank is going to be where it's sucking in all of the air, it's taking in a breath, and that's where it starts to tighten up the rotation. The rear flank is coming around, and that's where you start seeing the meso and the tornado going to drop from out of that rear flank downdraft. So that's that. But the forward flank, that's the big part of the supercell. Front, you heard like warm front, cold front, show of hands, show of thumbs. Probably heard front many different times. It's a boundary or transition zone between two air masses of different density and thus usually of different temperature. So that's why you hear warm front and you hear cold front. So a moving front is named according to the advancing air mass. Cold front if colder air is advancing. So if colder air is advancing from west to east, we have a cold front. if a warm front is advancing from west to east, or advancing just whatever which way it's advancing, then we have warm air that is advancing into the region. So again, whichever air is advancing, that's the front that's being pushed forward. So a lot of times when cold fronts come through, especially here, they come through here a lot in Chicago. I'm sure they come through a lot in the Midwest and things of that nature as well. But once they come through on the backside of that cold front, you can immediately feel like it'd be like 70 degrees, and then the next, like, once that cold front advances through and comes through, within the next hour or 2 hours or so, it might be 45 degrees or whatever else, because all that cold air has advanced through. So cold front, warm front. So when it comes to that, so Fujita scale, we talked about that, which is now EF scale. Funnel cloud, I think we're all pretty much familiar with that. But if not, what a funnel cloud is. A funnel cloud is a condensation funnel extending from the base of a towering cumulus or cumulonimbus cloud associated with a rotating column of air that is not, the big word here is not in contact with the ground. And hence, it is different from a tornado. So a funnel cloud, you see a funnel cloud, which a lot of people do all the time, and they go, well, there's a tornado. It's not a tornado. So a condensation funnel is a tornado, not a funnel cloud. It is in contact with the ground, debris cloud, things of that nature. So, but yeah, so a lot of people see funnel clouds and they immediately think that's a tornado. It's not, but it could obviously turn into a tornado if it touches the ground. So that is what a funnel cloud is, and a lot of people see them, call them dangly blitz, call them whatever they want to call them. But then Corey Adair says, and thank you so much, Corey, for stumbling upon my channel. Thank you so much. Corey Adair says, I stumbled upon your channel and I'm so glad I did. This is exactly the information I wanted to learn. Have you done any videos on how to read radar or the different views in radar? Yes, I actually did a thing on radar. Somebody help me out in chat here. I think that was my second or third video. So please, if you would please, Corey, go back there and you obviously go back there and look at radar. I break it down pretty simple and simplistic on how to read radar, at least here in the United States. So, and that, but would definitely love to help out if you have any questions or comments, or concerns about on how to read radar. So again, I'm going to take let's call it a 10-minute break. I will be back at 1:30 my time, 2:30 Eastern, so 12:30 Mountain, and looks like it's going to be 11:30 Pacific. So give me 10 minutes. Hopefully y'all stick around. But obviously I'm a father, so being a father comes first, and it's way more important than YouTube and everything else. So give me 10 minutes and I will be right back. So thank you guys, and I appreciate it. So All right, should be back live here. So, let me know if you can hear me. All good. Back in action here. So, some good stuff. Should be good to go. Give me a okay. Shane says thumbs up. Awesome. Uh, awesome. Thank you to my beautiful wife, who gives a thumbs up as well. So thank you so much. Let's jump right back in. Thank you to the Corey Adair says, laugh out loud. I'll be putting your name out there on Chaser streams. Oh, thank you, Corey Adair. I usually watch Brandon Kopic, but he has some car issues, so he's out of commission until the 4th. Yes, very familiar with Brandon Kopic. He's a great storm chaser as well. I actually am very good friends with, I call him a really great friend of mine, is John McKinney. So this is actually where a lot of the people in the chat right now are from John McKinney's stream. So Brother John McKinney is a very dear brother in Christ of mine. And obviously, Brother John's son is Freddie McKinney. So, but yes, thank you so much there, Corey dear. Corey Gherkin is good. DL Scales is good. Tanner is awesome. Tanner Charles, Freddie, they all bring, great skill sets, tools, valuable resources, a lot of great weather, just knowledge and things of that nature. So, but yes, thank you so much, Corey. I appreciate that. Any help, it's a lot of encouragement for me. I appreciate that. So definitely appreciate you getting my name out there. Thank you so much. So let's dive right back in. We just got done finishing talking about Funnel Cloud. We will now talk about, let's get in here if I get my cursor on the right screen. So ground clutter, you might hear that talked about as well when storm chasers are looking at radar. Ground clutter is basically, it's exactly what it says. It's a pattern of radar echoes from fixed ground targets like buildings, hills, birds. Sometimes the birds are stationary, things of that nature, near the radar site. So a lot of usually within about 25 miles of that radar site is usually where you will find a ton of ground clutter. So a lot of times ground clutter may hide or confuse precipitation echoes near the radar antenna, and that's true. So that's why it's kind of difficult to get radar images within about 25 miles of a radar site. We talked a little bit about it before, and it's a kind of a funny term. But the funny term is called the cone of silence. So once the so if you watch a storm go over a radar site, it'll actually fall into that cone of silence, and they will actually get hidden. That site will actually end up hiding it because the site can't see it due to limitations. So it will fall into that cone of silence. So that's when you're better off switching to a radar site that's as close to that other radar site that you're looking at where that storm is going over. So when a storm goes over a radar site, it falls into that cone of silence, and there's also a lot of that ground clutter that is happening around that. So that is ground clutter. A gust front. You will hear this term a lot too on storm chasing, things of that nature as well. Storm chasing, forecasting, whether it's Brandon Kopic, Tanner Charles, Freddie, Brother John, a lot of them, they'll talk about a gust front. And that is a leading edge of a gusty surface winds from thunderstorm downdrafts. So when we're talking about thunderstorm downdrafts, we're talking about like derechos, QLCS, squall lines, things of that nature. So when it comes to that and everything, so the leading edge will be that gust front. which again you will also see many times it would be associated with a shelf cloud. So we talked a little bit about before. If you see that shelf cloud coming at you, do not drive straight into that shelf cloud, because you are going to be met with most likely 70 plus mile an hour winds, heavy rain, precipitation that you're not going to be able to see, and things of that nature. So if you see a shelf cloud, you know the shelf cloud is part of a gust front. So you will most likely hear that quite a bit if you haven't already in the streams as well. Gust NATO. Show of hands here, show of thumbs, show of whatever. How many have heard the slang term gust NATO? So if you have, that's awesome. But to break it down, it's just a slang term for a gust front tornado. So a tornado that happens in a derecho, tornado that happens in the QLCS line, which is also an MCS line. So it's a small tornado, usually weak and short-lived, that occurs along the gust front of a thunderstorm. Often it is visible only as a debris cloud, so near the ground. So we're not talking a fully condensed condensation funnel. So gust nados are not associated with storm scale rotation, mesocyclones, and they are more likely to be associated visually with a shelf cloud than a wall cloud. So also know too, if that shelf cloud is coming at you, there's a possibility that there might be a gust nado in that as well. So again, they're usually weaker, but either if it's an EF0, EF1, whatever, we know that it is strong enough to cause damage. So that is what a gust NATO is. So jumping back to chat, Corey Adair says, Freddie is a hoot, and his dad is just so sweet. Yes, brother John is very awesome. I love watching his streams. He just has such a calming voice. I definitely agree with that. And Corey Dare says again, I live in North Carolina, a little place called Thomasville. When I was younger, during the summer, we had pretty bad storms. I remember my first gust front, just a long rolling black cloud. Yes, so rolling clouds are part of that too. Roll cloud, shelf clouds. So yes. So thank you so much, Corey Adair, for that visual, that image from North Carolina. So really do appreciate that. But again, gust NATO, getting back to gust NATO. Gust NATO, that's what a gust NATO is. So we will also look at a little bit here. We're getting to the H's now. And again, not to sound like a broken record, but just going to look at things that the majority of storm chasers look at, and the main kind of the main terms here. So high risk, that comes from the convective outlook. That is the highest risk that we can be given ever for severe weather. So if there is a high risk convective outlook for that day, that means there is a great risk for very, very intense tornadoes. And those high risk very rarely ever come out. Sometimes they'll come out maybe once a year. Sometimes they don't even come out for a couple years, because the atmosphere and the ingredients and everything just does not line up in order for a high risk to be issued. So those are the most extreme risk that are ever put out from the Storm Prediction Center. So, but again, when these come out, this is storm chasing like, this is what storm chasers like a lot of them live for. This is like they're super excited. This is like whenever they chase a high risk day, this is like the top of the mountain for them. This is super exciting for them. So high risk, very, 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 very rarely handed out. So hodograph, that is another one that maybe you've watched storm channels before. Corey Adair says it's their Super Bowl. That is a way better term than what I said. So yes, I would say that high risk would be like a Super Bowl to them. Yes, um, definitely. So people get really amped up for high risk. People get really, really excited. So Corey definitely nailed it by saying it's their Super Bowl. So Photograph. This is a uh, not a Nickelback song. That was Photograph. But a lot of people like to say, look at this photograph. So when if you look at a photograph, and as Lisa says here, can do an entire talk on the photograph. I don't know if you're talking about yourself, Lisa, or but yeah, definitely could be uh, photographs could definitely be a full scale video, multiple hours long on just what a photograph is, what it does, how things of that nature. But a lot of storm chasers will look at a photograph, and it is a plot representing the vertical distribution of horizontal winds using polar coordinates. So I know sometimes it gets the meteorological side of the thing. So a photograph is obtained by plotting the ends of the wind vectors at various altitudes. So we're looking at different wind areas. Vectors, they just mean different things. So when it comes to that, so and connecting these points in order of increasing height. So if you ever do see a photograph, and maybe I will do a video on photographs on how to read them and things of that. But if you ever look at one, the visual of a photograph, it gets scaled up as it goes higher. So interpretation of a photograph can help in forecasting the subsequent evolution of thunderstorms. So the NWS is constantly looking at photographs. They're constantly looking at different wind vectors or wind zones, wind areas, and how they are increasing in with those points in height. So on a high school level, not on a high school level, but on a higher, just a 60,000 foot view, that's what a photograph is and how it helps with representing and helping storm chasers. So again, look at this photograph. So that's what that is. So hook or hook echo, that is obviously a very, very, very big term that is used throughout almost every single live stream or every single storm chase. They'll say, I'm looking for the hook echo, I'm looking for the hook on radar. So what are they looking for here? So they're looking for, it's a radar reflectivity pattern characterized by a hook-shaped extension of a thunderstorm echo, usually in the right rear, or what we like to call the southwest side of the storm. Right rear part of the storm relative to direction of motion. A hook often is associated with a mesocyclone and indicates favorable conditions for tornado development. So once we see that hook on radar, we know that it's the mesoscale, or I'm sorry, I keep saying mesoscale, sorry. The mesocyclone is there, so the spin is there, it's rotating, everything's things of that nature. So, but remember, just because we see a hook on radar, it does not mean that the tornado is there on reflectivity. That's why we have to use velocity radar to help us really, if we're looking at just radars, like we're not visually looking at the storm itself. So the reflectivity is not going to tell us that the tornado is down, because the reflectivity is just going to pick up that hook, that hook echo. So that's why velocity comes into play for radar, and that's why correlation coefficient comes into play for radar. So hook, echo for that. HP storm. Another big terminology that's used out there in storm chasing. They'll look at the supercell and they'll go, is this supercell HP or LP? So HP is high precipitation, LP is low precipitation. So when you look at that, if someone says, oh man, this cell is a very HP cell. We're not going to see anything. It's the tornadoes. It's going to be impossible to see things of that nature. Those are indications of when they are rain wrapped inside of HP cells. So high precipitation. So you are not very well going to see, if at all, see anything inside of that HP cell. So again, HP storm or HP supercell, just in a nutshell, means it's high precipitation. So, and that precipitation can be hail, rain, things of that nature. So that's what HP stands for. Humidity. Well, I think a lot of us have felt the humidity this week. So if you, Corey says a lot of storms this year have been HP. I could imagine for sure. A lot of storms usually are HP. Like the majority of storms to actually see the tornado and everything else are very, very rarely do they come out of LP storms. So, and Brother Shane says Hewlett Packard. That would be awesome. That should be Hewlett Packard's slogan. That should be their ad campaign. Should be HP. Something to do with supercells or some supercells. There you go. They're super computers or something. So I think Brother Shane, you are on to something there with that, brother. So yes. So core punching HP cells is dangerous, and obviously the bear's cage. The bear's cage is obviously lingering inside of that HP cell as well, storm cell as well. So humidity, to get into humidity, I think a lot of us have felt that. A lot of us, especially here in the United States, it has been so humid here since about Monday, here in Chicago, since about Monday. So through right now, it's still been extremely humid. So humidity, what is it though? Just exactly? It's generally a measure of the water vapor content of the air. So popularly it is used synonymously with relative humidity. So if the air is humid, it's a lot of it's moist. It's a lot of vapor in the air, and that's why your clothes will start sticking to you. Everything else. So that's why when people go, that's why there is a difference between dry heat and wet heat. So humid, like here right now in Chicago, it's like it's a wet heat, and what that is, it means like there's so much humidity out there. You're gonna start sweating, and then all because of that humidity that's there, everything is just going to you're gonna stick in. The shirts, your clothes are gonna stick to you. You're gonna feel very just like you just walked into an oven and everything else. So so a lot of that. So humidity. Moving into the eyes. We talked a little bit about inflow bands or feeder bands, so we won't get into that. Inflow jets. So we talked about that before with the rear inflow jet just the other night when we talked about the ghost train. So inflow jets, they're local jets of air near the ground flowing inward toward the base of a tornado. So that's where the RIJ will be, which is the rear inflow jet. So that's exactly what an inflow jet is. It's just flowing inward toward the base of a tornado. So another thing you will hear too, and so you will hear inflow jet and those things as well. Another thing you'll hear too is an inflow notch. What is the inflow notch? This is where storm chasers love to be at. They love to be in the inflow notch. A lot of storm chasers, there's actually a saying in storm chasing that says, and I'll think of it here in a second. I just had it, but let me go on to it. So a radar signature characterized by an indentation in the reflectivity pattern on the inflow side of the storm. So that's where you're gonna see around the RFD and things of that, around the hook, you'll see the inflow notch. But this term should not be confused with the V notch. Supercell thunderstorms often exhibit inflow notches, usually in the right quadrant of a classic supercell. And thank you, Christian Arcos. for becoming a subscriber. Thank you so much for that. So, but sometimes in the eastern part of the HB storm, in the rear part of the store, rear inflow notch. So yes, so the rear inflow notch, that is where the storm chasers love to be at. So that is where they love to be, because that's where the inflow is coming in. That's where you'll have some clear skies. You'll hear you'll be able to get better footage of tornadoes themselves. So a lot of storm chasers love to be in the rear inflow notch, but that is also a very dangerous spot to be in. So when it comes to that, inflow stinger, maybe you've heard this term on sometimes too, is a beaver tail cloud with a stinger-like shape. So sometimes we'll say, oh, I see a beaver tail cloud. What they're talking about is a stinger-like shaped cloud. So that's what a beaver tail is. We'll move on to instability. We know instability is, again, it's the displacement, the acceleration and displacement of air parcels. So when a atmosphere becomes unstable, that is what's happening there, and that is for the greater potential of thunderstorms to rise from. So storms need instability here. So and if you see here, instability is a prerequisite for severe weather. So gotta have instability in order to have severe weather. So again, a prerequisite for that. So we will keep going on down here. We'll get into that stuff. So we will look at a big thing that we will see across a lot of whether it's max velocity or Ryan Holiol, or even live storm chasers themselves and things like that, when they're looking at whether it's radar, whether it's satellite imagery, things like that, they'll say, oh, I need to look at the jet stream, or see where the jet stream, or the jet streak as well. So if we go one up to the jet streak is a local wind speed maximum within a jet stream. So two different things there. There's a jet streak, there's a jet stream. So the jet stream is what controls our weather here in the United States. So the jet stream, and this is what storms ride off of and things of that nature. So, relative strong winds concentrated. Relatively strong winds concentrated in a narrow stream in the atmosphere, normally referring to horizontal high altitude winds. Yes, that's why airplanes ride the jet stream. So just to get to that real quick, because we got high jet stream there. So if airplanes going from west to east have a tailwind, because the jet stream comes from west to east, so airplanes save fuel and they save money and save time when they travel from west to east. But the inverse happens, and they do their best to avoid the jet stream. So that's why if you ever fly out from like Boston to LA on a Saturday, and the next day is Sunday, and you do the same flight again, it'll be a different path because the jet stream will be in a different spot. So they're trying to avoid that jet stream. So because if you hit the jet stream head on, you're going to lose time, you're going to lose money, and you're going to that's the main. So airplanes love going west to east, because that's how they save. But when they go east to west, they're constantly looking at where that jet stream is and trying to avoid that jet stream as much as possible. That's why you would never, if you fly east to west, you usually would never fly in the same path twice, even if you flew it one day and then the same time next day. So that's why airplanes ride the jet stream. So if we look at jet stream again, I digress from that. So it's a position of orientation of jet streams vary from day to day, and like I mentioned that. So the position is it flows day to day. So the jet stream can be elevated to a certain level today. Tomorrow it's going to be in a different spot. So again, going back to airplanes, they're constantly forecasting. They're constantly trying to look at where that jet stream is going to be. And again, as weather forecasting, constantly looking to see where that jet stream is going to be at as well. So when you go into that, general weather patterns, hot and cold, wet and dry, are related closely to the position, strength, and orientation of the jet stream. If you guys remember earlier this year, what was it, in May, there was that big talk and that big lingo that was used, which was called the omega block. That was the jet stream dipping down, coming back up, and dipping again. That looked like the omega Greek symbol, the omega. So that's what's called the omega block. So a lot of times the jet stream makes some weird looking type of patterns and things of that nature, but that's where the storms will ride upon. The storm systems will ride upon. So the strength and orientation, and then orientation of the jet stream. A jet stream at low levels, so lower levels in the atmosphere. And this is another big terminology used in storm chasing, which is called the low level jet. So if you hear low level jet, they're talking about the jet stream, but they're talking about it at lower levels, not higher up in the atmosphere. So that's the jet stream. And the jet stream is super important because, again, how that jet stream is orientated is how storm systems are going to ride off of that. So currently right now, just to give you a visual, currently right now, here in the jet stream is currently, if you want to see if I use my cursor here. So if we flow this way, and we flow up like this, and we flow, this is coming from the southwest here, like out of New Mexico. The jet stream is riding up like this. It's going up towards like Minnesota and all these other states up here, and then it's kind of coming around like this. So what's happening is because there's a ridge of high pressure here that's dominating the eastern and middle America, Central America right now. So what happens here is all the storms that are forming right now are all out here in riding this jet stream, which is why they're in North Dakota, they are in Nebraska, Kansas, and like that. That's why we're not seeing storms out here in the central, like Indiana, Kentucky, things like that, because there is a high pressure that's built up here. So what happens, that high pressure kicks off all of the high pressure says, oh, there's sinking air. The high pressure is sinking air. So when the air sinks, you're not going to have any storms because storms need air to rise in order to create convection, in order to create storms. So high pressure system is what comes in, and that's what gives us the nice weather, gives us sunny days, gives us hot weather, things of that nature. So right now the jet stream is riding over the top of that ridge, top of that dome, the high pressure dome or high pressure ridge as it's called. It'll ride up over that. And that's why like Indiana right now is being blocked. That's why Kentucky's being blocked. That's why like Arkansas, Tennessee, things of that nature are being blocked. Now there can still be a little bit of stuff, but it's not going to be any severe stuff that will pop up. But besides that, for severe storms, that's why right now they're all concentrated on like Wisconsin and Iowa and North Dakota and South Dakota, Kansas, and Nebraska. So just to get into that. So, all right. So, but again, that's the jet stream, and that's why it plays such a huge role into. So if someone says the jet stream, where is the jet stream? Where it's at? All of that is you're going to be your pretty much starting point to tell you where storms are going to initiate and storms are going to fire out of. So that's what it's writing from. So looks like we have Jonathan in here. What's up, Jonathan? Good to see you, brother. Glad that you're in here. I believe it is 8 o'clock in the morning your time in the UK. So thank you, brother, for being here. Corey says, how did you learn the knowledge you have about weather? Studying, watching a lot of just growing up. I've always been a weather buff. I can always remember it even as a young, early, maybe 5, 6, 7 years old, just loving weather. I watched a lot of the Weather Channel growing up. And then reading, getting into it, learning, watching videos, watching TV shows, watching forecast, and then just diving in and teaching myself. So like everything you see here that I'm teaching you is it's self taught from myself. Like I'm not a trained meteorologist. I'm not a degreed meteorologist. Everything is self taught. It's just years and years and years of experience teaching myself and perfecting the best that I can my craft in that. So, but it's just being always just wanting to learn more about weather because weather is so pivotal. It's an ever changing motion, right? It's an ever changing occurrence, a phenomenon that's outside. So yeah, so that is where my training comes from. Is self taught. It's helping. It's teaching myself along with videos, reading, a lot of things like that. So that is where a lot of my knowledge comes from, and yeah. So hopefully that answered that. So we'll go into the with the this is a term I've never heard of. Knuckles. I've never heard of this term, so this is new to me, and I've never actually ever heard it. Um, I've never heard it on a live stream. I've never heard it in storm chasing, but hey, we can all learn this together. So it's called knuckles. It's a lumpy protrusion on the edges and sometimes the underside of a thunderstorm anvil. So if we back up to what an anvil is once it hits the ionosphere, troposphere, I can't remember the sphere off the top of my head. It's one of the spheres. Once it reaches that very top of the sphere, it hits the sphere where there's no weather at. So that's why when an anvil hits that, it flattens out. So once it flattens out, because it cannot make any more weather, there can be no more convection, there can be nothing else. So then it flattens out, and that becomes what looks like an anvil. So I guess underneath that, there's a thing called knuckles. And if somebody can let me know if they ever find Sonic, that would be pretty awesome. So we have knuckles. We just gotta look for Sonic. So, but let's move on from that. So, Corey says, that's amazing. You could really be a teacher. I have been a weather buff my entire life, but trying to learn something complex is pretty intimidating to me. I appreciate that, Corey. Thank you. I think it's just, I think you have to really, you got to find, people who are just as excited as you are about weather, but they're willing to teach you in a way that makes it simplistic, right? So, a method, just like a method I like to when I teach at work and everything else, it's called the KIS method, right? It's called keep it simple. So everything that I should ever teach you, it should be simple for you to learn and to understand. So I shouldn't have to, get into like scientific, terms, and everything I teach should be simplistic enough for you to learn from. So if we follow the KIS method, which is, like I said, keep it simple, there's actually we can go deeper inside of that. You can actually say there's actually like what's called a 7-year-old method, or some call it a 10-year-old method. And what that means is that anytime as a teacher, that if we teach somebody, we should teach somebody and to where we can explain it enough and easy enough as if we were teaching a 7-year-old or a 10-year-old. So that means if we pluck like a 7-year-old or 10-year-old off the street, they should be able to understand the things that we are teaching. So and as well, so like again, keep it simple. And this comes from the greatest minds, people like Jeff Bezos and people like Elon Musk and people that run, high hundreds of billions of dollar companies. And the goal is to what is also called dumbing it down. So make things dumber. That doesn't mean that it makes people dumber. It means that it makes instructions easier. It makes instructions more clear, and it makes instructions more simple. So that's how we get better, and that's how as a teacher, I try to do that, to make it as simplistic as possible and not to where it's like an algebra test or something like that, so that's what I try to do. So land spout. We went through this a little bit too. Land spout, you will hear if they do see one. If a storm chaser sees one on the on the stream, or if a forecaster sees one as well, Max Velocity sees one, or if Ryan y'all sees one, or whomever else is streaming on YouTube there as well, or whatever platform. So a land spout, again, a land spout is it's a tornado. It is a tornado, but it just does not come from a rotating supercell. A land spout is formed by a non-rotating supercell, so it's not rotating at all. That is a land spout, but it still is a tornado, and it's very different. And it's actually kind of confusing when people say land spout and saying, "Hey, that's a tornado," because then people are like, "Oh no, that's not a tornado." But yes, it is a tornado. A land spout is a tornado. But for some reason, somebody one day said, "Hey, that's a land spout." So, but again, the meteorological definition is that a land spout comes from a non-rotating supercell, from a non-rotation. So if there's a storm up in the sky and it's not rotating, but a tornado comes from it, it's still a tornado, but they will say that that's a land spout. So, and the same for water spout as well. So when it comes to that, so let's look at. Sometimes you'll hear, and Freddie has talked about this before, and everything else. So, like lapse rates. So you'll hear lapse rates, and you'll actually see lapse rates in the National Weather Service Storm Prediction Center when they give outlooks, when they do things of that nature. They'll talk about lapse rates. So, not lapse as in our laps, but lapse with an E on the end of it. So the rate of change of an atmospheric variable, usually temperature, with height. So as temperature, so lapse rates means as its temperature is changing with height. So you kind of just think that in your mind. So steep lapse rates implies a rapid decrease in temperature with height, a sign of instability. So if there's rapid decrease in temperature as you keep going up higher in the atmosphere, in different layers of the atmosphere, that is a sign of instability. So sometimes on stream, you'll hear people say, "Oh, or you'll hear storm chasers, or hear forecasters or whomever say, "Oh, there's steep lapse rates," and that's what they're looking at, and that's what they're talking about. So it just says it helps to undersea instability. So awesome. So. When it comes to that, sometimes you'll also hear on stream when our storm chasers say, "Oh, this storm is taking a left turn," or "it's a left mover." So a left mover is a thunderstorm which moves to the left, which means it's moving. If you look at it on radar, it looks like it's moving to the left on radar. So if it's moving east, but if it looks like it's going to the left, it looks like it'd be going off to the north and back off to the west as well. So a thunderstorm which moves to the left relative to the steering winds and other nearby thunderstorms, often the northern part of a splitting storm. And then, so you'll have a left mover and a right mover if storms do split. So a lot of times storm chasers will have to choose and say, if a storm does split if it splits up, and say, which storm do I go after? Do I go after the left mover, or do I go after the right mover? And again, that is just them trying to come up with the best decision that they can make, and go from there off of that. So that is from a lot of that is from splitting storms. So left mover and a right mover. We'll get into sometimes people will say this. I know it's very rare, but maybe you've heard it, but it's a sounding. It's a term for a sounding, which is a loaded gun. So it's a loaded gun sounding. And it means it's characterized by extreme instability, but it's containing a cap. And as we talked about the cap earlier, the cap is, remember, a lid. So remember, so say where you have a crock pot, or you have something in the microwave that has a lid on it, you're capping all that pressure in there. You're capping all that in there. So So a lot of times, so sometimes they'll use slings. Sometimes the storm chasers are really into meteorology, and because there are degreed meteorologists who actually chase, there are people who do that. So, um, but yeah, they'll talk about a loaded gun sounding. So, and they'll say that it's such that explosive thunderstorm development can be expected if the cap can be weakened or the air below it heated sufficiently to overcome it. So if you hear loaded gun, that's what they're talking about. They're saying, "Oh man, the atmosphere is a loaded gun right now," and things of that nature. This is exactly what they're talking about. It's extreme instability. It's a loaded gun, and if that cap breaks, that gun's going to fire off, which means a gun's going to pop off. That things are going to start going haywire. So if you hear a loaded gun, that's what that means. Now, not to be confused with the shortwave trough, which we'll talk about, long wave trough. So shortwave troughs, you hear them a lot of times on streams and on storm chasing and things of that nature. So a long wave trough, a trough that is prevailing westerly flow aloft, which is characterized by large length and usually long duration. So generally, there are no more than about 5 long wave troughs around the northern hemisphere at any given time. So there's only roughly about 5 of these around the northern hemisphere, and their position and intensity govern general weather patterns. So hot and cold, wet and dry over a period of days, weeks, or months. Smaller disturbances, this is where we get into the shortwave troughs. This is what they eject out of the Rockies, they eject out of the mountains. So a lot of times you'll say, oh, you'll hear storm chasers say, oh, there's a shortwave trough that's going to be ejecting into the plains today. This is what they'll be talking about here once I start talking about this. So shortwave troughs are smaller disturbances, typically move more rapidly through broader flow of long wave trough, producing weather changes over short periods of times, a day or less. So again, so inside that long wave trough, you have what's called a shortwave trough, and that shortwave trough is what can change, like I said, like a day or less, like it says, it can change weather patterns inside of that for about a day or less. So when you hear a shortwave trough, this is what they're talking about. So they're talking about it's producing weather changes for about that day or so. So if you hear a shortwave trough is ejecting into the plains, then you're going to know that that shortwave trough is going to be changing the weather, which can bring thunderstorms, tornadoes, things of that nature for about a day or so. So that is a long wave trough and a shortwave trough all in together. So we talked about the low level jet already, so I won't go into that. We talked about a little bit. We talked about the HP storms, but the LP storms are just the opposite, the inverse of that. So that is your low precipitation, and that's really what storm chasers want to see. They want to see LPs out there for many different reasons, but when it comes to seeing tornadoes and getting those visual tornadoes and getting the ones that make it on the news and sell and make all the money and stuff, they want LP storms so they can capture the best images and things of that nature. So that's what they are out there looking for and hoping for is an LP storm and LP supercell. So LP, just remember HP high, so high precipitation, LP low precipitation. So they use that a lot in storm chasing lingo. LSR, you also hear them talk about LSRs. So they'll say, hey, I need to check the LSRs today. LSRs are local storm reports, and local just means local to that community, local to that city, local to that region. So a local storm report is issued by the local NWS offices to inform users of reports of severe and or significant weather-related events. So any tornadoes, high wind damage, things of that, they will get logged into this LSR report. So if you want, you can always look them up on the NWS website as well. I believe that the weather apps too have them in there. I do believe Radar Omega has them loaded in there. I believe that WeatherWise does too. I am not familiar if Weatherfront does or not, but you can click on that and you can enable, I believe, local storm reports to see when and where that there have been some LSRs reported. So get to the M's. So we're moving quite along here. So in the M's are mammatus clouds. Those are those kind of cool looking here rounded smooth, like a sack protruding down. So a round smooth sack like protrusion hanging from the underside of a cloud, usually a thunderstorm anvil. So when it comes to that, so looks like Jonathan says it's my daughter's birthday today. Awesome. Happy birthday to your daughter, Jonathan. So everybody please say happy birthday to Jonathan's daughter, please. So definitely happy birthday to her brother. So, but again, mammatus clouds. Brother John has shown a lot of these mammatus clouds on his storm chasing adventures, and also other storm chasers show a lot of those as well. So Jonathan says Aaron, so happy birthday to Aaron. Awesome. So but yeah, so mammatus clouds, very cool stuff. So MCC, I know we hear MCS, MCV, which I believe is on here as well, and MCC. So a mesoscale convective complex. It's a larger MCS. So just to know, if you hear MCC, it's a larger MCS. So and they're generally round or oval shaped, which normally reaches peak intensity at nighttime. So if you see, well, there was an MCC complex that came through, it's just a larger MCS that came through. So sometimes storm chasers will say MCC. Majority of the time, they're always basically going to use MCS for that. So, and you can this gets into more of the definition and around that. So MCS, we know it, you'll hear a lot of MCS. That's like one of the main terminology used in storm chasing. So mesoscale convection system, a complex of thunderstorms which becomes organized on a scale larger than the individual thunderstorms. It normally persists for several hours or more. So we're talking about QLCS. So all QLCSs are MCSs. So you're not wrong if you say an MCS came through last night and the weather the weather people say it was a QLCS, because the QLCS, which is quasi-linear convection system, is an MCS. So the thing is this: all QLCSs are MCSs, but not all MCSs are QLCSs. So just remember that. All QLCSs are MCSs, but not all MCSs are QLCSs. So anytime you hear a quasi-linear convection system, it's just the mesoscale convective system. That's what it is. So look at that. So good. So medium range, forecasting. In medium range, they say, hey, we'll look at the medium range forecasting. It means 3 to 7 days in advance. So that's the medium range outlook. Mesocyclone, that is the region of rotation in the supercell of the thunderstorm. So it's typically around 2 to 6 miles in diameter. And a lot of times you will see storm chasers right under that mesoscale. I'm sorry, I keep saying mesoscale. Right under the mesocyclone. And you can see it spinning and turning and everything else. So, and it's most likely almost always found in the rear flank downdraft of the supercell. So when they are in the RFD, they are in that little hook, and that's where the mesocyclone is, and that's where it's spinning, and that is where the tornado is going, if it was going to happen, is going to take place at. So mesocyclone. So there we go. We talked about this in mesoscale, so we'll get into that. Mesonet, they might mention it sometimes on live streams and things of that nature, but mesonet, it's a regional network of observing stations. So usually surface stations designed to diagnose mesoscale weather features and other associated processes. So what they're looking at wind speeds, temperature, things of that nature. So mesonet, can measure different things in their stations there. So sometimes you might hear mesonet. We talked about micro burst a little bit with a downburst. Remember, a microburst is a small concentrated downburst. So deal with that. So we talked about high risk being number 5. That's the highest. Moderate risk is number 4. That's the second highest risk that can be given by the NWS SPC. So talking about that, we'll get into let's see, multiple vortex, right? So you'll hear a lot of multiple vortex. Oh, that tornado was multiple vortex. Oh, it's multiple vortices, right? It's the same language. So multiple obviously means more than one. And again, so it's a tornado in which 2 or more condensation funnels or debris clouds are present at the same time, often rotating about a common center or about each other. So a lot of times when you see the multiple vortices and you see the multiple, they'll be dancing around each other, or they will be dancing around the main circulation, the main condensation funnel. So if you look at multiple vortices, they're really easy to spot, and you can see they kind of take like the same path, either dancing around themselves or dancing around the main vortex. So again, it's multiple condensation funnels or debris clouds present at the same time. That's what a multiple vortex tornado is, and that is usually that's usually the strongest ones. The ones that have multiple vortices inside of them, multiple suction vortices, things of that nature. So multiple vortex tornadoes, remember, you're not just dealing with one vortex, you're dealing with multiple vortex, and that's why they're so damaging. So you may have heard mushroom cloud, like from like an atomic bomb going off, or something like, or nuclear bomb that creates like a mushroom cloud. So when it comes from that, great point, Corey. Corey says usually means a strong tornado. Yes, if you see a tornado with multiple vortices, it's usually very, very strong indication that tornado is extremely strong. So that means obviously not just a normal tornado. That tornado is different. It's got multiple vortices, and it means business. So Corey, great job, great point out there. But to get back into mushroom cloud is like maybe if you've seen videos of nuclear bombs going off, things of that nature. As that cloud rises up, it hits the top of the sphere again, and it mushrooms out. So it's a thunderstorm with a well-defined anvil rollover, and thus having a visual appearance resembling a mushroom. So that's exactly what it is. So that's the mushroom cloud. But again, that's usually that I've ever seen is from like a nuclear explosion or things of that nature. So Jonathan says, right guys, got a party to sort out, gotta run, love and prayers. Thank you, Jonathan. Thank you, brother. To you all, have a great 4th of July. You lovely bunch of people. Thank you, Jonathan, for joining in all the way from the UK. Thank you for helping, for modding, for being a great supporter, great encourager. Definitely appreciate that. So thank you very much, Jonathan. God bless you, brother. Have a great 4th of July, brother. Appreciate it so much. So, Corey says, a great visual for horizontal vortices is Tuscaloosa, Alabama. Yes. Good point out there. And if you're, that is a great tornado in visual cues, right? In visual acuity that has strong horizontal vortices just dancing around it. So when you see horizontal vortices, like we're not just talking vertical vortices, we're talking horizontal vortices, that means it's really, really strong. So, I mean, because basically the difference is you got the difference in the air, that it's basically the cloud is able to not even touch the ground. That it's so strong, it's pulling off the vortice off of the ground basically, and it's able to swirl around it. So you're talking that's how strong it is. So not only are you getting hit by a vertical vortice, you're getting hit by a horizontal vortice, which is just as dangerous. But yes, that Tuscaloosa, if we're talking about from 2011, April 27th, 2011, that, my friends, was a very, very disturbing and or very, very nasty tornado. But yeah, NCEP. Let's get into the ends now, real quick. NCEP, National Centers for Environmental Prediction. So this is actually what the SPC is inside of. So if you think about the NWS as a onion, there's layers to the NWS. So inside the NWS sits the NCEP. So if you think of that as a layer, now what sits inside of the NCEP is the SPC sits inside of the NCEP. So yes, the SPC is a part of the NWS, but it feeds into the NCEP, which feeds into the NWS, which the NWS feeds into NOAA and into NOAA. So you think about there's even more layers that go on. And if I'm not mistaken, I think it rolls all the way up to, which is either the Department of Commerce or the Department of whatever it is. That's the highest jurisdiction in the government. So think about NOAA as having multiple onion layers. So if anybody talks about the NCEP, there's a couple of these inside of NOAA, inside of the NWS. And one is the SPC. Another one is the National Hurricane Center down in Miami. So they are also another NCEP. And yeah, just to kind of give you an overall of that. But Corey says, hope you have a safe and blessed 4th. It's 3:30 here. I will catch back up with you in the morning. So incredibly blessed to have found your channel. I hit the notification bell. Good night, all. Oh, thank you so much, Corey. Thank you so much for your interaction, for your information, for being, just being an encourager, being a supporter. So thank you very much, Corey. Appreciate that. God bless you. Have a great 4th, and appreciate all of your help. Thank you so much. And I might say that your last name reminds me of Brett Adair, which I think spells it the same as well, if I'm not mistaken. So you may or may not be familiar with Brett Adair, but if not, he does a lot of great work as well. So thank you very much, Corey. There. So if we move on real quick, next rad that's radar. That's what we just talked about. It's called Next Generation Radar. Negative tilt trough, right? When it's negatively tilted. So this comes into play. It's an upper level system which is tilted to the west with increasing latitude. So i.e. with an axis from southeast to northwest. A negatively tilt trough often is a sign of a developing or intensifying system. So if a trough goes negatively tilt, it's usually a sign that it is starting to intensify. So a lot of storm chasers will look at and go, oh, what's that trough? Is it negatively tilt? So what it's saying is it's basically kind of falling back towards the northwest. That is negatively tilt. There's NOAA. We talked about NOAA. Nocturnal, that's just nighttime. Nocturnal tornadoes. So you might hear storm chasers talk about nocturnal tornadoes. National Severe Storms Laboratory, again, that's inside of that's inside of NOAA, so that's another thing inside of NOAA. We get into the O's now. Occluded, right? So occlusion. So we get into occlusion. Corey says, real quick, I would say big possibility. The spelling of dare is a Texas side. The spelling of dare is a West Virginia side. Okay, so you guys, 1D is added just over to the West Virginia side. So, okay. I knew it looked very familiar, though. So, but awesome. Thank you for that information, Corey. And again, thank you so much for your support. So have a great 4th, and God bless you. Thank you so much. So occluded mesocyclone, which is Corey says we went separate ways. Awesome, awesome. Thank you. But yes, an included mesocyclone is it's going to be what they talk about occlusion. So like if the tornado's on the ground, they'll talk about occluding. So a mesocyclone in which air from the rear flank downdraft has completely enveloped the circulation at low levels, cutting off the inflow of warm, unstable low air. So it's starting to occlude. So that rear flank downdraft has enveloped the circulation at low levels. So now all the inflow, all of the juice, all of the air that's needed has been sucked out, and that's why tornadoes, when they occlude, when this happens, when they occlude, they don't stay in the direction that they were going. They tend to go off to the north or off to the northwest. So that's why if you're trying to chase a tornado and you're on the northwest or north side of it, which is obviously it's always obviously a position you don't ever want to be in, the occlusion can happen. It can overtake you there with the occlusion. So moving on from that, outflow boundary. Again, we talked a little bit about that with boundaries. So it's a storm scale or mesoscale boundary separating thunderstorm, cold air, which is outflow, from the surrounding air, similar in effect to a cold front. So you'll hear like storms go outflow dominant. They'll create an outflow boundary away from them. So that's it's talked about a lot on streams and on what you call it, storm chaser streams. So we're talking to the PDS watch, particularly dangerous situation. If you ever underneath a PDS watch or even a PDS warning, that's a step level up from just a regular normal warning or a normal watch. So PDS is that next level up. So when it comes to that, get into popcorn convection, which is slang for showers and thunderstorms that form on a scattered basis with little or no apparent organization. So sometimes you might say, "Oh, we got some popcorn thunderstorms popping up, some popcorn showers." This is what they're referring to and talking about. So, and then just the inverse of the negatively tilt trough, the positive tilted trough is tilted to the east with increasing latitude. A positive tilt trough often a sign of weakening. So as we talk about negative being stronger, positive means weaker. So if it's negative tilted off towards the northwest, it's stronger. If it's positively tilted off to the northeast or east as well, then it becomes a weaker system. So just remember that when it comes from that. So we'll keep moving down here. We'll skip. There's no Q anyways. Yeah, we talked about rain-free base. Sometimes you hear that. It's just the base of a storm that doesn't have any, with no visible precipitation beneath it. So so sometimes you might hear that as well. RFD, we hear that on almost every single live stream. Someone's going to mention the word RFD, arbor flank downdraft. And again, for those of you who are new or those of you who don't know what the RFD is, thank you so much for all of you who are still here at 2:34 in the morning Central Time, 3:34 in the morning Eastern Time, 1:34 in the morning Mountain Time, and 12:34 in the morning in Pacific Time. So thank you all again for being here. Appreciate that. Please like and subscribe. So again, so if you're not familiar with what an RFD is, it's a region of dry air subsiding on the backside of and wrapping around the mesocyclone. So remember, it's on the backside, so it's going to be on the west side, which 99.9% of storms are going to come off from the east to the or from the west to the east. So this is wrapping around the west side of the storm, the far backside of the storm, wrapping around the mesocyclone. It is often visible as a clear slot wrapping around the wall cloud. So, and then that's what creates that notch. That's that notch that we see, that hook echo, and then the notch that's there. So, or the rear inflow notch, to be more specific. So Scatter large precipitation particles, rain, and hail at the interface between the clear slot and wall cloud may show up on radar as a hook, which we talked about. Thus, the presence of a hook or pendant may indicate the presence of an RFD. So if we see a hook, you are going to be seeing RFD. So just remember that. So RFD, I'm actually not going to beat that over the head, but as we know, but again, if you're new and you're just learning about it, RFD is what's going to be talked about, and pretty much mention every single stream, every single storm chaser stream who's chasing tornadoes will most likely mention RFD at least one time in their stream. So reflectivity, we talked about that. That's just showing us what the storms look like and everything. So relative humidity, we talked about that. We talked about humidity, relative humidity. It's all used interchangeably. Roll cloud, that's associated with the Arcus clouds, which is associated with like derechos and shelf clouds. So if you see a roll cloud as well coming at you, it's part of the gust front. So you know it's very strong winds. There possibly could be a gustnado in there, but they look like roll clouds because they look like they're just rolling about. That's what it looks like. So that's why they call them roll clouds. A rope, you'll hear terms of tornado, right? Rope, wedges, stovepipe, things of this nature. So a rope, it's a narrow, often contorted condensation funnel, usually associated with the ending stage of a tornado. So when the tornado starts to rope out, that means that it's coming to the end of its life cycle. So if you hear somebody say, "Oh, it's roping out," that's exactly what they're talking about. So, and they say, "Oh, it's in the roping stage." Roping stage means that the same thing. It's the dissipating stage of a tornado. So, we want from that. Scud. Scud is talked about a lot. Brother John has talked about Scud. Other storm chasers will talk about Scud. It's small, ragged, low cloud fragments that are unattached to a larger cloud basin, often seen with and behind cold fronts and thunderstorm gust fronts. Such clouds generally are associated with cool, moist air, such as thunderstorm outflow. So that's why sometimes when you see it on the video, or hear the storm chasers talk about it, you will hear them talk about Scud. Scud is, as Shane mentions here, almost every single day with Scud. Yes, for some reason Scud it's just as popular a lot of times as RFD. So that gets talked about a lot. So we'll talk about severe thunderstorm. We know what that is, severe thunderstorm. But some of you might not know exactly what constitutes as a severe thunderstorm. Like, what is the criteria that has to be met for a severe thunderstorm to be a warning to be issued? So if a severe thunderstorm is a thunderstorm which produces tornadoes, what can hail of 0.7 inches or more in diameter, or winds at 58 miles per hour or more. And only one of those criteria has to be met. So you could have a storm at 52 miles per hour wind, but it's got hail at 0.75. So they're going to ding a warning. So not all those three criteria have to be aligned for there to be a severe thunderstorm warning. So only one of those criteria has to be met. But those are the three things that are used in order for them to issue a severe thunderstorm warning. So that's what constitutes a severe thunderstorm warning. Shear, that's another huge thing you're going to hear storm chasers talk about. Wind shear. Well, what is shear? We hear shear all the time. Wind shear, all this stuff. What is it? What it is basically is it's variation in wind speed and or direction over a shorter distance. So as you go up in height and as you change levels in the atmosphere, so what they're looking at, or what we're looking at as meteorologists are looking at, storm chasers are looking at, they're looking at shear. So is there different changing wind directions as you go up? Because you need shear for tornadoes. You need spin because shear creates that spin. So if you have a lot of shear, you have a lot of spin in the atmosphere. So that's what they're looking for. So Shear usually refers to vertical wind shear, the change in wind with height. So again, as I mentioned, as you go up higher in the atmosphere, the wind changes with height. But the term is also used in Doppler radar to describe, yes, radial velocity and over short horizontal distances as well. So yes, so wind shear, again, that they're looking at is they're looking at the change in wind with height. So because if you're at like 10,000 feet and the wind is blowing to the east, if you go up to 15,000 feet, now it's blowing west. They're just looking at, as you keep going up, does the wind go in different directions and to where it can create spin, and that's what you need in the atmosphere. You need spin for a tornado. So to me, one of the most ingredients, and again, how tornadoes form, is not scientifically proven. It's not, it's unknown. But one of the most main ingredients that you need for a tornado to possibly take place, you need wind shear. You need spin. You need that type of directional shear in order to have that tornado happen. So definitely shear. Shell cloud, we talked about that. Shortwave, we talked about shortwave trough, so we'll get into that. Slight risk, that is number 2 on the risk level. So just to go from 1 through 5, it's going to go marginal, that'll be green. It's going to go slight, that'll be yellow. It's going to go enhanced, that'll be orange, so that's level 3. It's going to go moderate, that's going to be 4. And then it's going to be high, which is 5, and that's usually going to be white or like a form of like a purple or something, but it's usually like a white color. So, but that's how they're color coded, and that's how they go. So they go marginal, slight, enhanced, moderate, high. Those are the 5. Those are the 5 risk that the NWS uses. So we talked about soundings already before with the photographs. We talked about SPC, speed shear. It's same thing basically as wind shear. We talked about splitting storm as well. Squall line, we talked about that. Squall line too, that's also used too as well. Like you hear, the squall line came through. It's a solid or nearly solid line of band of active thunderstorms. So QLCS, they're going to say, that's a squall line, things like that. So when it comes to that, so we're going to also look at straight line winds. We talked about that. So instead of tornadic winds, which are rotating winds, things like that, these straight line winds just mean it's coming straight at you with no rotation. So when it comes to that, getting into other clouds here, suction vortex, it's usually several suction vortices. They're usually that small, very intense inside of that tornado circulation. Usually there's several suction vortices typically are present in a multi-vortex tornado. So much of the extreme damage associated with violent tornadoes is attributed to suction vortices. So suction vortex is that. If you are not familiar with what a supercell is a thunderstorm which is a persistent rotating updraft. And again, it has to be rotating. If it's not rotating, it is not a supercell. So that's what differentiates that. So when it comes to that. So again, if it's rotating, it's a supercell. If it's not rotating, it is not a supercell. So, and again, these things are right movers, and what that means is with right moving storms, it just means they frequently travel to the right of the main environmental winds. So if the winds are blowing off to the east, they're going to be to the right of that. So they're going to be right movers. So they have that wind to help them shear and everything else to drive that. So that's why they call them right movers as well. So we'll move into, we're getting close here. So we're gonna move into, let's see what other, tornado is what it is. It's a violently rotating column of air in contact, remember, in contact with the ground and extending from the base of a thunderstorm. So it's got to be extending. but it has to touch the ground. So remember, it has to be so. So it has to touch the ground. So a lot of times you'll see the condensation funnel, but if that condensation funnel again does not touch the ground, it is not a tornado. So tornado family, sometimes you'll hear storm chasers talk about that. It's a series of tornadoes produced by a single supercell. So again, if it's the same supercell that's creating a bunch of tornadoes, it's cycling and it goes back through, creates more, goes back through. It'd be called a tornado family. So when it comes to that, so sometimes you hear storm chasers talk about a towering cumulus cloud. They talk about a towering cumulus. It's a cloud element showing a appreciable upward vertical development. So it keeps rising and rising and rising. So they'll say, "Oh, that's a towering cloud." Towering just means it keeps rising and rising up. So that's what that is. So keep going on here. Now, sometimes you'll hear them talk about the triple point. This is a key point and part in where severe weather can happen at, things of that nature. So the triple point, it's the intersection point between two boundaries. So it's a point between a dry line, alpha boundary, and cold front, things of that nature. So often they focus on thunderstorm development. So you'll hear sometimes them talk about triple point. That's what they're talking about. They're talking about the intersection between two boundaries. That's a triple point. So triple pause. That's a upper boundary of the troposphere. So usually characterized by abrupt blast rate. Sometimes you'll hear them talk about triple pause as well. And there's troposphere. Trough, we talked about troughs already. TVS, I talked about this before. TVS is the tornado vortex signature, which you see on velocity. So velocity, when you're looking on velocity radar, that is what's going to show you a tornado vortex signature, and that's where that couplet comes in that we talked about before. So usually they'll talk about the couplet. So that's going to be a tornado vortex signature. So we'll look at updraft. Updraft is exactly what it means. It's a small scale current of rising air. So an updraft, it's just rising air. So we hear that in the updraft base. It's basically an alternate term for a rain-free base. So you might hear that as well. But updraft, hear that pretty much all the time. So then you might hear the term upstream and downstream. So upstream means it's going towards the source of the flow or located in the area from which the flow is coming. And downstream would mean the inverse of that. So we'll look at, let's keep going here. We're getting close here. So see that what they wall cloud. It's a localized, persistent, often abrupt lowering from a rain-free base. So if you see a wall clouds can range from a fraction of a mile to up to nearly 5 miles in diameter, and normally are found on the south or southwest inflow side of the thunderstorm. So that's but again, not all wall clouds rotate. So, but if you see a wall cloud, it is a pretty good precursor to possibly a tornado happening. So we can move in from that. Warning, we know what a warning and a watch is. Watch just means conditions are favorable. So if you don't know, a watch means, hey, the NWS has looked at the conditions. They're saying they're favorable for development. They're favorable for so they'll either put out a severe thunderstorm watch or they'll put out a tornado watch. A warning means that it's imminent. A warning means that it's been spotted. It's been radar indicated. A warning means that it has hit the criteria for them to warn and say, and for the particular area to say warn and take shelter. So again, watch, favorable, warning, happening. So watch does not mean current time. Warning means current time. So water spout, we talked about that. Wedge, yes, wedge is a slang for that large tornado. It's at least as wide as the ground is tall, so it's as tall as its base. So that's why it looks like a wedge just wedged in there. So when it comes to that, so we'll look at wind shear. We talked about shear already, and then we go. It looks like if I remember correctly, yeah. So that is a lot, and I know I skipped over a lot, but I skipped over a lot of the main ones that um, really that storm chasers don't usually ever talk about, things that nature. But from all of that, that's a lot of what storm chasers lingo is going to talk about. It's a lot of what they're going to be talking about on their stream and things of that nature. So again, some storm chasers get more down into the weeds and more down and dirty into the meteorological side of things, and some storm chasers keep it at a 60,000 foot view. So, but hopefully, it was, broke it down for you guys here. Um, that you're able to get somewhat a little bit more acclimated with some of that. And again, all of this can be found. Let's go back up here. So it's a great tool. It's a great to just learn, and it's called Weather Glossary for Storm Spotters, which is the same thing for storm. It can be used obviously for storm chasers as well. So because a lot obviously storm chasers are storm spotters. So in the big grand scheme of things, because they're spotting the storm. So, but yeah, this is found on the National Weather Service webpage, and you would just have to search for Weather Glossary for Storm Spotters. So that will give you a lot of good knowledge of what basically a lot of the storm chasers are looking at and what they are going to be talking about on their streams. So you're not kind of like lost, and you're not kind of like, oh, what the heck are these people talking about? I don't know what's even going on here. So, so when you think about that, so questions, comments, thumbs up if you guys are still awake. It's almost 3 o'clock my time in Central Time, so appreciate it. It looks like we still got 77 in here at almost 3 o'clock on July 4th, on 4th of July. So, which is a 250th celebration. So that's pretty awesome. But yeah, give me a thumbs up. Give me some sort of, indication that you are still active, you're still awake, you're still learning. So, but good. So, looks like we got Shane still. Looks like we still got Peter still from all that. So that's good. So, but yeah, it's very good to So hopefully this is some good information. And again, hopefully you're able to you can find this again for your. I'm gonna go back and look at some of these again. It's on the National Weather Service webpage, which is www.weather.gov here in the U.S. So you can find that there. So that just helps a lot to understand that. So, because I know when I first started watching storm chasers and everything else, I didn't know what the heck cape was and cap and none of that stuff until I taught myself and everything else and learned about it from other sources as well. So, so if you don't understand, still don't feel like you are on an island, because I did not know a lot of these things for quite some time as well. So, when it comes to that, so, but yeah, so it's pretty cool that just to learn those and everything else. So, but yeah, so that's the whole topic teaching for today, for tonight. That's the main training and teaching and things of that nature. So, but through all of that, is there any maybe lingo or terms that are not on here, or that I did not mention, maybe that you guys either use yourself or that you have heard used and you know what it is, or whatever? But I'd like to know, because maybe this glossary missed out on some of the things. So, but yeah, like maybe there is something that you guys have heard of or still are using your storm chasing weather communities as well. So, but yeah, let me know there if that's what you know or what you've heard or anything. So, I'd like to know that. Definitely like to know that. So, when it comes to that. So let me know there, please. Let me know if you've heard of any other terms or anything. And that would be awesome. Let me know. Let me know. Still got 79 of you in here, um, that's awesome. I got 80. Got 80 of you in here. That's awesome. It's almost 3 a.m. It's almost 3 a.m. Central. 4 a.m. Eastern, 2 a.m. Mountain, 1 a.m. Pacific. And I believe Peter's time over in the UK, I think Peter's time might be almost 9 a.m. I think Peter's about 6 hours ahead of where I'm at. But yeah, so let me know. Let me know if you have any other terms that you might know that I might not have mentioned or talked about. So definitely would like to know that. So for sure. So currently got 80 people in here. Uh, so that's pretty awesome. So 80 people in here on July 4th. So um, so that is pretty awesome. So that is really awesome. Peter says 5 to 6 hours ahead, depending where you are. Okay, great. And Peter, I am going to, whether it be later today or sometime tomorrow, I will contact you on Discord to see if, um, talk to you about helping out the homeless and things of that nature. So appreciate that. So I will be contacting you there relatively shortly on that um, when it comes to that. But yeah, still surprised that there's still 79 of you in here at 3 a.m., which is basically when everybody is sleeping time. Uh, but sometimes I find late night streams are actually sometimes better than a daytime streams. Um, when it comes to that, and I know this stream got started a little bit later because of Brother John didn't sign off till I think it was after midnight. Um, so that's why this got started a little bit later. But besides that, it's been pretty awesome. And again, if you have not liked or subscribed, please like and subscribe. That does help me out a lot to help my channel, to help out the algorithm, to recommend me and things of that nature. So please like and subscribe. Definitely appreciate that. Um, but yeah, so definitely working on some new graphics here with the new overlays, working on certain things here. Implementing Streamlabs into this is what you see here. This is what Streamlabs, the overlay that I'm using. So yeah, so just so it's really good to implement that. So so very cool stuff. Also going to be, I believe, starting. I do believe I will be streaming again today on the 4th, but I am going to start streaming to multiple platforms. So I'm planning on streaming to Facebook as well simultaneously. So simultaneously streaming to YouTube, Facebook. Probably most likely might throw in Twitch there as well, and so just trying to grow the stream through different platforms, but definitely gonna throw in Facebook. But I'm thinking about throwing Twitch in, and maybe another one as well. So that's coming in the pipeline. Is doing some simultaneously multi-streaming. So from that. So but yeah, so very happy with hopefully it's been a great, a great chat. It's been a great hopefully it's a great lesson. Hopefully you guys were able to learn, quite a bit, some new lingo, some new things. So hope that's been good and for you guys. So but yeah, hopefully you all are having a great day right now. Majority of you are probably sleeping, which is cool. I appreciate that, you sleeping and falling asleep. Um, Falling asleep, um, whatever, that's cool. But yeah, good stuff. It's been a lot of great stuff. So yes, so if you are still awake, or if Annie's still in here, looks like Peter might be the only one who is still awake or still active. Please put in a thumb up, please, or a wave, or something. So let me know that you are still up and at 'em at this time of night. Because looking like I am going to be ending my stream here in about, we'll call it about 4 to 5 minutes. So, but yeah, so great stuff there. But before I end my stream, I'd like to take you guys all over to the NWS Outlook and see what today's Outlook looks like for July 4th. So let's look at that together. So it looks like for today, July 4th, it looks like the NWS has a very, very a very, very small little area of enhanced risk over here on the very far eastern seaboard of the U.S., followed by a big old slight here, followed by big old marginal here throughout the middle of the, getting towards the mid-central, getting over to the central over here. So, and then it looks like we got this big old slight here out in Kansas, Nebraska, and marginal as well. And it looks like we have Janet Wright. Thank you very much. Hello to you too, Janet. Hope you are having a great day, morning, night, wherever you are tuning in from. So thank you very much, Janet. Appreciate that. Hi to you as well. So categorically speaking, we're looking at enhanced. So we're looking at level 3 out of 5 over here. Looking at level 2 right through here. Level 1 is a dark green. We get back into level 2 here. Throughout the central plains, so the high center, basically the central plains. So if we move on and take a look at the tornado parameter, the tornado outlook is a 2% risk, and it's a very, very small circle, very, very small corridor, but again, a 2% risk is still a risk. So take it seriously if you happen to be in Wichita, Kansas, Newton, Kansas, Great Bend, Kansas, Hutchinson, Kansas, and Derby, Kansas as well, around those vicinity there. So it looks like central Kansas to south central Kansas. So if you happen to be there, that is where the threat for tornadoes lies at for today on July 4th. And so, again, not a huge risk, but a 2% risk. A 2% risk is still a risk. So, so if Brother John is chasing today, I'm not 100% sure if he said on his stream or not, if he's going to be out chasing today or not. If he did, he would be right down in this section. So, but besides that, so that is day one for today. It's probably being driven by out here. So the site is being driven by hail. It's a hatched area for hail, 15% hatched area with a sig 1 intensity. So, but the main thing, if you come all the way over here on the East Coast, wow, they have a 45%. This is not seen very often for wind. 45%. They have a 45% sig 1 honed in over here where this enhanced risk is at. So this 45% wind, severe wind, is what's driving the severe or the enhanced outlook. So if you're in Baltimore, Washington, D.C., Arlington, Virginia, Columbus, Maryland, Alexandria, Virginia, you are going to most likely see some very intense winds today on the 4th of July. So let's see what they are calling upwards to. Let's see if they talk about maybe some of the wind speeds they are trying to get into here. Let's go out to let's see here. Let's go. Maybe I missed it. Mid-Atlantic, yeah. Let's see. Any wind speeds? I'm trying to see what they're predicting. I don't see any wind speeds, but either way, you're going to be facing some very, very, very strong winds, especially with that. So that is, again, not 45% is a very high, very, very high risk at 45%. So, so that's going to be some damaging winds. So, so potentially for some so potentially for some widespread damaging winds. So, when it comes to that, so that's today, July 4th, which is a huge holiday here, obviously in the United States. So, let's go back and look at tomorrow for day 2. Day 2, they don't really have much. They have a slight, right now they have a slight risk set up. So they have any tornado outlook. They don't even have a tornado outlook at all for tomorrow, which is July 5th. So when it comes to that, so they're not predicting much at all in the way of tornadoes right now, or any type of tornado percent right now for Sunday, which would be tomorrow. So this is probably wind driven again. Let's see. Yep, it's going to be wind driven. So it's, again, that categorical outlook is driven by wind over. The slight is driven by wind over here. So day 3. Let's see if they have anything for day 3. Day 3, they got a marginal risk. Up here, what's the probabilistic? 5%. Okay, yeah, so they have a just marginal there. So it looks like the stormiest parts today for July 4th is going to be, over here around the Baltimore, Washington, D.C. area, and possibly, potentially, some storms firing up here in the Kansas, south central, South Kansas, around the border of Oklahoma. So, yeah, so that is the categorical outlook. That's what it looks like for today for July 4th right now currently. And this is this most likely. I'm assuming just got updated right close to 1 a.m. my time. Actually, it got updated right at 1 a.m. my time. So that's pretty cool. So when it comes to that, but uh, but very cool stuff. So yeah, so it looks like today again the stormiest places is going to be Baltimore, Washington D.C., possibly New York and Philadelphia, and Tulsa maybe, as well as Wichita, Kansas. So from that, so that is the overlook for that, and they will update it again 8 a.m. my time, Central Time. So things can change, but obviously there might be a little bit of a different outlook as things change all the time, as things become clearer as the day progresses. So from that, so if you're still here, I appreciate that. 76 of you still in here. Appreciate that so much. It's just that's wild. 76 of you in here on July 4th, at 3 a.m. in the morning, and I'm talking about weather outlook. So that's pretty wild. That's pretty cool. So when it comes to that, so definitely awesome. Definitely cool stuff. So and it's just really cool. So um, but again, I'm just sitting here, blabbing about weather outlooks, and hopefully, hopefully you guys are, able to see some of that and understand that. So Peter says, "I'm still here." Cool, awesome, Peter. Thank you. Awesome, man. I appreciate that, brother Peter. Appreciate that so much. So for you being here. So definitely good stuff. Definitely great stuff there from you, Peter. And again, thank you, Janet, for chiming in and saying hi. Appreciate that. Again, got 76 in here, which is awesome, which is brilliant, and appreciate that so much. So plans are to stream again today, which I say today because it is 3:13 in the morning. So plans are to stream again later today on the 4th of July and to talk about so to discuss some more weather topics, and I have some more weather topics lined up, so to teach you about that and have some great discussions. Looks like Janet just chimed in and says, "What is the outlet for or outlook? I believe outlook." So, looks like, what is the outlook for St. Louis, Missouri for this weekend? I am from St. Louis, Missouri. Well, let's take a look at St. Louis. So the outlook is for as if we're talking about severe weather here. So for St. Louis, it looks like St. Louis is. Let me make sure this is day one. This is day one. So it looks like St. Louis is in a level 1, which is marginal. So you do have a chance for some thunderstorms, but a very small chance of thunderstorms on Saturday, which is today, for you there, Janet. So very small chance for you there, but you do have a chance nonetheless there in St. Louis there. So that's today. And let's look at tomorrow for you. So tomorrow, if we go to the outlook for, well, actually, let me go back. Make sure there's no tornado. Yeah, there's no tornado. They don't have you at all in a tornado outlook at all. There, Janet, for you in St. Louis. Wind. It looks like they got a 5% over you for wind. So a very small chance again for a wind. Some type of wind damage, things of that nature. So type of hail. Looks like they don't have any hail highlighted over your region there, Janet. So looks like, so today, very small chance for maybe a brief, strong thunderstorm, possibly a thunderstorm, but a very small chance at that at best. So then if we look at tomorrow, if we look at tomorrow, categorically speaking, not even a threat. this little green highlighted just means thunderstorms. It's not even a level. It just means there's a possibility that a thunderstorm might pop up, but it might not. But for it to even be severe, probably not. So that's what all this highlighted yellow or very light green is. So no tornado outlook for you at all on Sunday there, Janet. Nothing that they have anywhere across the whole United States. So they say everywhere has. So there's nothing that for them to even circle or to make a any type of. So everything is less than 2%. So there's nothing marked on the map at all. So wind looks like you don't have any wind threat on Sunday, Janet, because you don't have anything shaded for you. There's nothing shaded for you over there at all. And hail looks like nothing is for the hail either. So it looks like Sunday there might be a very, very, very slim chance of maybe just a general thunderstorm, but it doesn't look like anything severe possibly on Sunday as they have right now. Obviously things could change, but right now that's what they have. So so that's what your forecast looks like from the severe side of things. Whether it's tornado, wind, hail. That's what the outlook looks like for you, Janet, over in St. Louis, Missouri for this weekend. So looks like a pretty good weekend. Besides that, so looks like there's not going to be just from what they're calling or saying that it's not going to be like any really bad storms or things of that nature. But again, if there's a chance, there's a chance. So you just it's got to be weather aware. Appreciate that if you're weather aware and weather ready. So yes. So hopefully you have a great weekend there, Janet, in St. Louis for the 4th, and celebrating the holiday and just having a great time there. So Peter says, did you put the links to the info you discussed today? I do not have the links in the I don't have them yet, but I can put them in the description. So. And Peter says, I'm mowing my gardens today, so drop me a message in Discord. I will be on later when I'm done. Awesome. Thank you, Peter. I appreciate you, brother. Appreciate that very much. But yeah, I'll put the links in the description of this video about what, just to find the glossary and to find the terms, about the storm chasing and everything else when it comes to that. So really great stuff, really awesome stuff when it comes to that. So hopefully, Janet, that helped you out and that helped you, with your kind of your outlook here for today, Saturday, and then for tomorrow, Sunday. So Peter says thank you. Thank you very much, Peter. I appreciate that very much. Thank you. Awesome stuff there. So definitely very thankful for that. So. But yeah, hopefully you guys learned some stuff today. Hopefully you guys enjoyed the stream. Hopefully you guys, still 86 of you in here at 3:19 in the morning. Chicago time, Central time here. Still 80. Now there's 88 of you in here. So, if there's anything you guys want to learn or talk about weather-wise or to discuss, that is what. The Fireside chat is all about. It's about learning. It's about just getting to know each other. It's about understanding and helping each other grow in this community. If you want to self-promote, please feel free to self-promote. If you want, and always feel free to always talk about the Lord. Always talk about Jesus. Always talk about God. So you can talk about God whenever you want. You can self-promote whenever you want. Because again, I'm here to help people. I'm here to help my brothers and sisters. So, but yeah, so still 87 of you in here. Again, and it's 3:20. So, in the morning, and it's very awesome, very cool stuff, very great stuff. So hopefully we've been learning quite a bit of stuff here. So. Just been streaming for just a little over 3 hours now. So very cool stuff. Very appreciative And again, stream got started a little bit later, but it's okay. It's awesome. It's perfect. And just very thankful, very, very gracious for that. Very, very awesome for that. So, but again, if you're new to my channel, please, please like, please subscribe, please conversate in the chat. Please, be active. Looking to, just looking to have fun, looking to learn. So again, if you're new here, the way that I do things is the very first part of my stream will be teaching a topic, whatever that day that I have lined up to teach about. And today's teaching was about storm chasing lingo, storm chasing verbiage, storm chasing a lot of words and a lot of different types of sayings that are used by storm chasers. So, please, again, if you're new here, that's the way that I do. I always teach a topic first, and then we get into the fireside chats, and we get into different types of tornado talk, types of weather talk, and any other talk that comes along with that. So, very cool for that. Very cool. It's very thankful, very blessed for all of you. Let me know if you guys have any questions, comments, or concern, and if not, I will be ending the stream here in about 1 minute. Since we did just look at the outlook, we did just look at the outlook for the next couple of days, and we did a really great session on storm chasing lingo and storm chasing verbiage. So very thankful, very blessed to have you guys. If you guys don't have any questions, comments, or concerns, we'll be ending the stream here shortly. So again, thank you all. Thank you to everybody who's still in here. Thank you to everybody who's still listening. Appreciate that so much. You all are awesome. You guys are just so cool, so awesome, so everything. So again, so thank you just to all of you, but obviously number one, thank you to obviously my Lord and Savior, Jesus, because without him, none of this is possible. So you guys all have a blessed 4th. You guys all have a blessed day. Hopefully I will see you guys here later on today when I stream again. And with that being said, and as like always, be brave and let the Lord guide your way.